All right, welcome back to the conference room. We're now going to have a keynote and Q&A by two Andrews, and the first of whom is attending virtually. This is Andrew Tan from Toyota Oceania, who we've heard this morning. So I'm not going to introduce him anymore. But then Andrew Stewart, who's the second speaker. He is from Wood. He's the Executive President of Strategy and Development at Wood PLC, which is a global leader in consultancy and engineering across energy and the built environment. I will leave it to that and will ask them to introduce themselves some more. If needed, please enjoy the keynote address.
Thank you. I think everyone can hear me and see my slides. Thanks again for this big invitation to represent Toyota at this conference. I'd like to acknowledge the land that we're meeting today. Me being in Perth, Western Australia, we're meeting on Noongar land. So I pay my respects to them. So I'm Andrew Tan. I look after Toyota Oceania in the Oceania region. And the corporate head office is in Perth, Western Australia. So once again, thanks for this opportunity to give you an update on the world's first hydrogen export project, and I'll also be touching on future developments. So these are the topics I'll be touching on today. I'll give a brief introduction on the current hydrogen demand internationally, speak about our hydrogen supply chain, discuss our world first project, mention variations of our system, and give you an update on Toyota's activities in Asia and Europe, and then discuss the various cost reduction scenarios in our roadmap moving forward. So this graph from last year's International Energy Agency's report shows the projected global hydrogen demand. Global hydrogen production will increase 4 times to 290 million tons in 2050 and 7 times to 520 million tons in 2070 in their sustainable development scenario. Hydrogen use will expand to all sectors and reach a 13% share of final energy demand in 2070. The technology development, excuse me, such as I speak of today, will make hydrogen and hydrogen-based fuels more realistic for the decarbonation of mobility sectors such as heavy trucks, aviation, and marine transportation, as well as for the production of chemicals and steel. The distribution of solar irradiance and wind potential in the next slide will be a key factor in obtaining green hydrogen. Toyota 4 years ago estimated that the global potential for hydrogen from renewable energy sources to be about 19,000 gigawatts in terms of power, but is much bigger than that now. In the future, IEA estimates that green hydrogen should be cost competitive even in the case of exports. And the Middle East, Australia, North Africa, China, and some South American regions are suitable for the production of green hydrogen. This slide shows the major gas trade flows internationally in 2021. Considering the construction of a hydrogen supply chain from regions with a green hydrogen supply source, we believe that the LNG trade flow should be a great reference for the future. In addition to this, part of this gas flows may become the flow of blue hydrogen in the near future. As you may know, Toyota has been engaged in the LNG business for decades, and we are eager to apply our valuable experience in building this hydrogen supply chain. Excuse me. This map shows the hydrogen importing and exporting countries and the expected routes of their trade by 3 categories. Firstly, under development, secondly, under MOUs, and thirdly, highly expected. Asia and North Europe are assumed to be importers of hydrogen, and it is inevitable to rely on imports for most of the required volume. More countries may announce or plan new hydrogen routes in the future. The potential of hydrogen sources today and the trade for LNG today are the basis of this picture. So we believe that we can play a major role, mainly in the storage and transportation of hydrogen in this flow with our technology. Now I'd like to introduce our hydrogen supply chain. Chiyoda has provided many energy and environment-related plants and systems over the years. Now we are applying and developing the engineering capabilities cultivated through these efforts to decarbonization technologies. This table essentially summarizes the typical business fields and related technologies that have been utilized. For example, technologies related to LNG can be converted and applied to building large-scale production plant of hydrogen, of liquefied hydrogen, and technologies related to synthetic gas and fertilizers can be converted and applied to efficient large-scale production of ammonia. We are also developing various green energy technologies, and in particular, the construction of a hydrogen supply chain using the MCH LOHC method has become a top priority for us. MCH stands for methyl cyclohexane and LOHC for liquid organic hydrogen carrier. Since Chiyoda Corporation was established in 1948 by Mitsubishi Oil, Chiyoda has been conducting technological research and development based on a corporate philosophy of energy environment in harmony. There are many examples of Chiyoda contributing to environmental protection and energy issues through the commercialization of proprietary catalysts and catalytic processes independently or in collaboration with partners. Chiyoda started the research and development of MCH technology in 2002, so this hydrogen race that we're all in now is not new to us. We developed catalysts for the MCH dehydrogenation, a technological breakthrough, and in 2011, we successfully demonstrated the commercial viability. And the next pilot plant was in 2014. So following the test and further evaluation, we announced that the performance of developed dehydrogenated catalyst, MCH, was technically verified and the catalyst ready for production use. This is an overview of Chiyoda's Spera hydrogen system. We named the process Spera, which is the Latin word for hope. This flow shows the LOHC hydrogen supply chain system using MCH as the hydrogen carrier. In countries and regions with abundant hydrogen resources, toluene will be converted to MCH by hydrogenation and transported to countries and regions for hydrogen demand. In the process of MCH dehydrogenation, hydrogen is extracted and supplied to the demand side where it is needed, utilizing our catalyst. Toluene, which is left in the dehydrogenation process, is entirely recovered and sent back to be used again as feedstock. The amount of toluene lost in this cycle system is extremely low. Essentially, toluene is the carrier for the hydrogen. The features, advantages, and realistic possibilities of LOHC with MCH are shown here. Both toluene and MCH have a liquid temperature range of -100 degrees Celsius to +100 degrees Celsius. So they can be handled as a liquid at ambient temperature and pressure anywhere on Earth, and is chemically stable and is fairly low risk. So essentially, it's a liquid at ambient temperature and pressure. Due to these characteristics, MCH has a significant advantage as a hydrogen carrier, as it can utilize existing petroleum and petrochemical facilities and transportation infrastructure, as well as related standards and regulations. It can be a realistic solution for the acceleration towards a hydrogen society. For all of you old enough to remember, whiteout or liquid paper is MCH. That's the main solvent for this. Now I'll touch on the world's first global hydrogen supply chain demonstration project. Based on the results of our basic research and development of our technologies, we have conducted the world's first end-to-end global hydrogen supply chain demonstrating transporting MCH produced in Brunei Darussalam to Japan. This demonstration was subsidized by the Japanese government through AHEAD, which was formed by Chiyoda Corporation, Mitsubishi Corporation, Mitsui & Co., and NYK line. The project was successfully completed in December last year. We achieved the objective of international marine transportation of hydrogen by MCH and supplied the hydrogen that we dehydrogenated into a power station and combusted it for energy. ISO containers were used because of the small volumes, but tankers will be used in the future for large commercial scale transportation. This successful demonstration, including the production, transportation, extraction, and use of hydrogen, is a significant step towards the social implementation of a hydrogen value chain towards the realization of a hydrogen society. So let me now touch on the variations of our system. So MCH can be dehydrated on a large scale at the port of importation, and hydrogen can be supplied by pipeline to factories, power plants, or refineries. The MCH can also be transported to decentralized hydrogen utilization sites, utilizing the existing logistics of petroleum products. The MCH stations will be particularly useful for a wide range of mobility needs, including large vehicles such as fuel cell buses and heavy-duty vehicles or trucks. We have been developing and demonstrating several technologies to achieve this application. From 2015 to 2017, Chiyoda Corporation conducted a demonstration test of this MCH system for hydrogen stations and succeeded in continuously producing hydrogen that met the quality standards. This slide shows a 3D model of an MCH hydrogen refueling station. A prototype conceptual design is introduced in this model. So the photograph down here shows our prototype, which is essentially a 40-foot container. The table shows the hydrogen supply volume, capacity, and number of vehicles refueled per hour. In Japan, deregulation of hydrogen station using MCH is underway, and we are expecting the increase in demand from society. In addition, Chiyoda has established a system that can stably produce MCH using hydrogen obtained by electrolysis from fluctuating renewable energy sources, and verified this system in demonstration pilot tests from 2014 to 2018 at our R&D center in Yokohama. This result makes an important point because renewable energy will be effectively utilized as green hydrogen without loss in the future. The ability to store large quantities of hydrogen stably over the long term in the form of MCH will lead to stable, long-term storage of green energy, including its use in emergencies. Essentially, MCH can be stored as a big battery. Now I'm going to touch on activities we've been doing in Asia and Europe. In March 2020, Chiyoda, together with Mitsubishi Corporation, entered into an MOU with 5 Singaporean companies to collaborate towards achieving a sustainable hydrogen economy in Singapore. The Singapore government announced its long-term low emissions development strategy, which aspires to halve emissions by 2050 from its peak in 2030, with a view to achieving net zero emissions as soon as viable in the second half of the century. Working closely with Chiyoda as a key technology and supply chain solution partner, the 5 local companies, as you can see, City Gas, PSA, Sembcorp, Singapore LNG, and Jurong Ports, will identify and demonstrate the use of cases using Chiyoda's MCH technology. All parties are collaborating to evaluate the technical and commercial feasibility of hydrogen usage and develop hydrogen business for import and utilization in Singapore. Moving forward, this year, Chiyoda together with Mitsubishi Corporation have signed an MOU with Sembcorp Industries to explore the feasibility and implementation of a commercial scale supply chain to deliver clean hydrogen into Singapore using Chiyoda's Spera hydrogen technology. We aim to further discuss and study a global decarbonized hydrogen supply chain. Based on the MOU, Chiyoda will accelerate its work on the hydrogen value chain business towards energy transformation, contributing to a long-term CO2 reduction in Singapore and global decarbonization towards a sustainable future. Furthermore, in July this year, Chiyoda and Mitsubishi Corporation entered into an MOU with the Port of Rotterdam Authority and Kool Terminals in the Netherlands to jointly study importing hydrogen on a commercial scale utilizing Chiyoda's MCH technology. The Port of Rotterdam released its hydrogen master plan in May 2020. The authority aims to promote the development of a hydrogen supply chain in Northwest Europe and become a hub for hydrogen imports, where hydrogen is estimated to be imported up to 200,000 tons in 2025 and up to 400,000 tons in 2030. And by 2050, an estimated 20 million tons of imported hydrogen will flow through the port annually. Chiyoda's hydrogen storage and transport technology is expected to play a pivotal role in technology and related business opportunities. We will provide engineering studies centered on MCH LOHC technology to promote the import and use of hydrogen, aiming to contribute to carbon dioxide emission reductions and realize future carbon neutrality in Europe. In March 2020, the Hydrogen Utilization Study Group in Chubu, Japan, was established with the aim to expand and demand for hydrogen in the central industrial region in Japan. Chiyoda is part of this council. The member companies are examining the possibility of large-scale hydrogen utilization and building a supply chain for stable use of hydrogen. It is estimated that there is a hydrogen potential of 40,000 tons in 2025 and 120,000 tons in 2030, provided that the hydrogen price is equal to the switchable cost of each demand sector in the central region. So now let me touch on the cost reduction scenarios and roadmaps for us. Now, when we consider Japan as an example of a hydrogen demanding country, it is an urgent task to establish a global hydrogen supply chain to import large quantities of hydrogen and achieve commercialization around 2030 to realize carbon neutrality by 2050. We have shown here the three hydrogen carrier options: ammonia, MCH, and liquefied hydrogen, in addition to LNG. The solid lines represent technologies that are technically ready today, whilst the dotted lines represent emerging future technologies. Each hydrogen carrier has its own advantage and time frame to establish its technologies, and the suitable carrier would depend upon the individual situation and conditions. While these carriers will coexist, the MCH method today, with its technical readiness, could be a realistic solution to establish a global hydrogen supply chain, accelerating the transition of a hydrogen society. I've mentioned that the MCH method is ready for commercial application. Economies of scale is the biggest factor to reduce the cost. But in order to further reduce the cost, we are vigorously promoting proprietary research and joint technology development. We will make the steady progress in both the cost reduction and the business expansion based on this technology development. This chart shows the results of a Hydrogen Council meeting organized by the Japanese government, in which we have estimated the amount and price of hydrogen supply needed to build a hydrogen society in Japan in the future. Based on our technology, development and business demonstration to date, we will move toward a semi-commercial scale supply chain by 2025 and a commercial scale supply chain by 2030, targeting the described hydrogen capacity and price as shown here. For example, targets are priced at $5 to $6 per kilogram by 2025 and $3 to $4 per kilogram by 2050. These are landed prices at point of use. Chiyoda believes with our current technology, we are close to achieving these prices. Chiyoda updated our medium-term management plan in May this year to develop new business and reinforce existing business activity. We support the international community's carbon neutral objectives and aim for sustainable growth by using our extensive experience in engineering and technological capabilities, including hydrogen as an alternative energy source, to accelerate the transition to a carbon neutral society. Mirai at the top means future in Japanese. Our Mirai engineering would be to make the most of engineering solutions to address social challenges and contribute to the society's sustainable development. By using our proprietary MCH technology as a key technology and by collaborating with various partners around the world, we are committed to realizing an early implementation of a hydrogen society. We look forward to making partnership with various companies construct the hydrogen supply chain and contribute to realizing this hydrogen society. Thank you very much for your kind attention.
Improvising here because technically we have 10 minutes left for questions. Is that on the cards?
It was.
Is Andrew still around? The other Andrew, sorry. Is it possible to ask Andrew from Toyota any questions? Oh, awesome. Are there any questions from the audience? I'm going to ask an embarrassing one. Not sure if I didn't pay attention, although I tried. How many kilograms of hydrogen can you package in the toluene?
Yes, that's not a correct question. How many? Yeah, that's a difficult. Well, maybe the best thing to say is I can't give you the exact numbers, but let's just say that if we're talking pricing currently, you know, we're very close to being commercial. So whilst I understand your questions around whether it's productive enough to send it with the toluene, I think, well, my answer is essentially it is commercial. And because of its makeup in terms of its chemistry, it can sit in your glass right now without any boil off.
Okay, great. Thank you very much. Any other questions? Yes, please come to the microphone and introduce yourself, please.
Naushad Haq from CSRO. What is the carbon intensity from start to finish of your MCH hydrogen?
Yeah, we would have to sign an NDA to give you an answer for that, but there of course is a carbon intensity number, and mostly that's in the dehydrogenation side, where it's an exothermic process where we need some heat to dehydrogenate with our catalyst.
Any more questions? Well, I think then we'll just hand over to Andrew Stewart from Wood. Thank you, Stuart. Andrew, sorry.
Thank you.
Thank you. Good afternoon. Testing 1, 2, 3. Can you? There we go. Well, good afternoon. It's wonderful to be here today. And after 2 years of lockdown, I think it's 18 months since I've been able to attend a conference. So for all of you that survived Melbourne lockdown like myself, had the joys of homeschooling, it is wonderful to be back in a hybrid format. So thank you for supporting the conference. I thought I would start actually just to come a little bit, raise the eye line up and just talk about what's happening in the world around us. And of course, I'll just get my clicker to work here. No, that's okay. There we go. Thank you. So I work for Wood and we're listed on the London Exchange. Of course, being headquartered in Scotland, we were uniquely positioned for COP26. So I thought just to anchor this discussion, I would reflect on the highlights reel from COP26. And we were fortunate enough to host around 3,000 incredible minds through our office in Glasgow through the 2 weeks. So here are my highlights reels, and I'll hopefully share some colour and depth to each of these points. So the first thing I would say was this was the first COP where the corporates turned out in force, where business was really there to get things done. And I've never seen that before at a preceding COP. So for the first time, I think in history, you will see net zero being a fundamental business principle in which organisations will start to organise around. And it's wonderful to see that in the lead up to COP, around 75% of the global greenhouse gas emissions are now covered by net zero commitments. So this is now a core business principle. And, you know, the challenge for all businesses is not insignificant, and the pivot is ginormous. I was with one of our customers today, BP, and of course, BP, you know, as a carbon intensive part of this solution are making a major pivot a 40% reduction in their oil and gas output by 2030, and sending 30 to 40% of their global CapEx to their low carbon business. These are major, major pivots by business and are right across every boardroom. These are now real issues. The second point I thought I would leave with you was around the money. Wood is a service company. We provide materials and muscle, but clearly nothing is going to happen without capital. And what was a really pleasing outcome from Glasgow was the Glasgow Financial Alliance. And that was about private enterprise coming together and aligning their CapEx allocation to the net zero objectives. And that was incredible. That was 450 corporations representing 45 countries. And the numbers are eye-watering. Most estimates are north of $100 trillion to decarbonise the global energy system. And, you know, the obvious consequence of that amount of capital going to net zero is, you know, the inflationary pressure that creates. So the investor community would challenge me to say $100 trillion going to decarbonise the energy system is an inflationary force, because the demand for green businesses, green technology, green talent will far outstrip supply. And that is true. That is absolutely true. But I would argue that the cost of inaction is harder to measure, but, you know, we don't really have a choice, because infrastructure abatement, resiliency, response to climate disaster, you know, those costs are ginormous too. So I'm not sure that we have a choice, but it is wonderful to see, you know, the engine room of the world being business committing to aligning their CapEx programs to net zero. The third one there was around the methane reduction. All of you will know how potent methane is as a greenhouse gas. And I spent a number of years in the US, and I've driven around all the major shale basins. And of course, US shale, you know, produces around 8 million barrels of oil a day, about 10% of the global oil and gas production out of the US and in shale. And when I'd be in a truck driving around the Permian Basin, the guys would often say, "Can you smell the methane?" And of course I would say yes. And they would say that is the smell of money making. And that may be true for today, but the costs for tomorrow come later. And I think that's the real challenge with this situation, is the costs need to be borne today for the benefits that come in the future. But it's wonderful to see such a commitment to reduce global methane emissions reductions. And finally, there are all sorts of pledges around the phasing out of fossil fuels, whether that be coal, whether it be changing out internal combustion engines for electric vehicles, etc. A lot of unstoppable momentum in that regard. And my only thoughtfulness here is that how this unfolds will look very differently in each part of the world. That simply replacing, you know, the internal combustion car in Melbourne, but everyone recharging their EV using coal-fired power is not going to leave a positive impact on the environment. So however the energy transition unfolds, it will unfold differently in each region at different paces, because the economics and the context is different. Just to sort of anchor this in terms of spend, in terms of new oil and gas developments, the forecast between now and 2050 is around $16 trillion in developing new oil and gas developments, but there's 26 trillion assigned to carbon management and carbon abatement of the existing hydrocarbon fleet. So that again is a tremendous pivot, you know, in a relatively short period of time. And of course, even under a net zero scenario, every model shows that hydrocarbon is still in the energy mix, around, you know, 20 million barrels of oil a day from around 100 million barrels of oil today. So hydrocarbons will be in the energy mix in a net zero world. Sorry, I'm not having much luck with the clicker here. I might revert to the mouse. So I suppose for any business, they were the sort of highlights, reels or summary from Glasgow. And I think for any business, how do you navigate such massive changes to keep the business relevant and to make sure the business is sustainable in terms of providing jobs and providing returns to the investors? And like any corporation, we, you know, as part of our strategic planning process have undertaken scenario planning as a way of sort of putting some boundary conditions around how could the world around us unfold, and how do we as an organisation create a winning proposition no matter how it unfolds and at what pace. So I thought from our scenario planning, I just put up some provocative statements around how we think the world is going to unfold. This is by no means every eventuality, but it does help inform our strategic planning process. And unsurprisingly, we do think the world will electrify and renewables will be a winner in the electrification of energy. The second point I would say is that the consumption of energy, 60% of energy will ultimately be consumed in the electron form, and 40% of the energy will be consumed in the clean molecule form. And of course, that's where hydrogen fits in. Biofuels is growing rapidly in our portfolio, and that's because we need to achieve a net zero aviation industry. And again, I'll speak a little bit about the solutions being developed in that particular area shortly. And of course, hydrocarbons will be used less so for combustion, but more so for materials to replumb the global energy system. And for all companies, the pivot is not without challenge. My company, we were born out of North Sea oil and gas. We were 90% upstream oil and gas only a few years ago, and today we're less than 40%. And that's been a very tough journey because we need to convince a number of stakeholders that we can earn sustainable returns, contributing to a healthy planet and generating the required return on capital. And I think that has been the challenge for any business, to show the investors that you can, make the energy transition successful and earn fair reward for the risks that you take on. So if I went to the clean molecule, none of this I don't think will be particularly surprising, but as I said earlier, I do think to change the world, business is the engine room. And for green hydrogen to really accelerate, it needs to make economic sense. And across our green hydrogen portfolio today, these are the three areas that we're seeing rapid advancement to make green hydrogen more commercially attractive. Of course, the first is the cost of electricity, the cost of renewable electricity. And pleasingly, in more parts of the world today, renewable energy is becoming the most cost competitive form of energy and able to undercut the traditional forms of fossil fuel energy. And that's becoming increasingly the case around the world and is certainly a major enabler for green hydrogen development. Globally today, 30% of the world's electricity is from renewable sources, and we only see that number accelerating, and that is a major contributor to green hydrogen uptake. The second one, I'm sure there's some OEMs, some electrolyzer OEMs in the room, but clearly the technology advancement, even in a short period of time, has been incredible. And I would just say thank you for the huge advancements that have been made in electrolyzer technology. Right now, we buy electrolyzers around the world for our clients, and typically we're paying in Aussie dollars about $1,500 to $3,000 per kilowatt for a PEM electrolyzer. And working with our electrolyzer partners, we anticipate that cost will come off by about another 30% between now and the next 5 to 6 years. So the technology advancement in electrolyzer technology is unreal, and it is certainly coupled with affordable renewable energy, making green hydrogen a bit more possible. And of course, in some parts of the world, green hydrogen will struggle because of the need for water. And of course, to make 1 kilogram of hydrogen, you need 9 kilograms of water. So in some parts of the world where water is scarce, or the cost of demineralizing water or desalinating water, that can be a major cost prohibitor to green hydrogen production. So hopefully that gives you a sense of what we're seeing in terms of green hydrogen uptake. So how is hydrogen made today? And what are sort of the compelling economics behind each pathway? So today, 70 million tonne of hydrogen, dedicated hydrogen, is produced globally, and 95% of that, of course, comes from steam methane reforming. And it's not only about making green hydrogen cost competitive from a price point, but it's also a challenge on volumes. And I want to speak to that in a moment. But if I went to, green hydrogen, specifically the largest electrolyzers today, around 10 megawatts, producing around 2,000 meter cubed an hour of hydrogen. And you can see, the sort of cost ranges there depending upon, the electricity supply and water availability. But you get a sense of, what is the price benchmark today? Well, what is Wood seeing in the projects that we're delivering around the world today? I think steam methane reforming, 95% of the energy of hydrogen produced today comes from natural gas, from steam methane reforming. And of course, you know, if a 10 megawatt electrolyzer can produce 2,000 meter cubed of hydrogen, you know, a steam methane reformer, a single train can produce 180,000 meter cubed an hour of hydrogen. And the volume is important for hard to abate sectors. The production cost there that I've shown for steam methane reforming, that is grey hydrogen, so that is without carbon capture and storage. You know, the I suppose price uplift if the unit comes with CCS is around 30 to 50% above the production cost shown there. So, you know, that is why certainly Wood advocates for a price on carbon, because it doesn't matter how good technology advances, it will always be cheaper to throw greenhouse gas into the atmosphere for no penalty. And technology, not taxation, does not work to make, you know, a hydrogen at scale environment for this to be a compelling pathway, and it needs to be. So we do see blue hydrogen as an absolute critical ingredient to bring scale to the hydrogen economy. If I look at hard to abate sectors, so steel, so if the world's population increases by a staggering 80 to 90 million people every single year, you know, steel is going to be a major contributor to greenhouse gases. And of course, today, steel production, I think, accounts for about 8 to 10% of the global greenhouse gases emitted comes from steel production. And of course, 1 tonne of steel requires 0.7 of a tonne of hydrogen. So volumes through steam methane reforming together with carbon capture and storage is the only way to bring hydrogen into steel manufacturing at pace now. And ultimately, of course, that blue hydrogen hopefully will be substituted for green. But we need to hit these hard to abate industries right now. And certainly our experience from around the world is steam methane reforming and carbon capture is the only way to do that at the volumes needed. But quite a unique challenge. So I thought Andrew from Chiyoda really covered the moving it piece. So how we look at this from around the world is, you know, Wood is involved in all of this. And our simplest way of expressing this would be making hydrogen competitively, moving it safely without as much cost as possible, and obviously creating demand side use. And I think if you follow the news, the IEA said this week that the demand for green hydrogen is lacking, and that is putting the outlook for the hydrogen sector in an uncertain territory. Hence, scale is important. And in some cases, green hydrogen makes sense. In others, steam methane reforming with carbon capture makes sense. You know, certainly Wood doesn't have all the answers, and there is some amazing technology from Chiyoda there in terms of transport vectors using toluene. Of course, there's methanol and there are other forms, but you know, we have partnered with Honeywell UOP. Honeywell UOP have an amazing technology called eco-fining, and this is about making sustainable aviation fuel, net zero aviation fuel. And in the middle of that eco-fining unit is a Wood hydrogen plant. And I can tell you that this is commercially viable. We are building plants around the world today, and jet zero air travel is absolutely becoming a near-term possibility through partnership. We could never have achieved this on our own. If I jump across to mining, we're working with a global miner. This is a green hydrogen undertaking. And what this client has asked us to do is to come up with a green hydrogen plant for deployment at all of their major mine sites. And clearly the benchmark here is to undercut the cost of diesel for their heavy haul trucks. And what's really interesting about this program, because it's quite a mature outlook, the customer is looking for a standard green hydrogen facility, and they want us to optimize the hydrogen facility for the complete portfolio. So this means that a green hydrogen plant at one mine site may be suboptimal for that actual mine site, but for the portfolio, it makes sense. And this is a great way to look at a portfolio of green hydrogen plants so that across the portfolio, this is an NBV positive undertaking for the client. And again, in this particular case, where the demand point is right next to the production point, green hydrogen absolutely makes sense for the volumes. If I talked about, 95% of hydrogen produced today through reforming, Here's a great example from a pharmaceutical company that we've worked with in Germany. And this is about recutting traditional steam methane reforming. And in this particular case, we're using a carbon abatement approach at the start of the process. So we're using solar arrays to preheat the reformer. And, you know, this is a relatively inexpensive solution, but it takes about 30 to 40% of the greenhouse gases out of their hydrogen production, which is a very important part for them to meet net zero. So it is about repurposing the current fleet as well as deploying, you know, that very new technology. It was really fascinating to listen to Andrew from Toyota about toluene. In toluene and methanol, we're not really seeing anything beyond some sort of conceptual studies at the moment, but certainly in ammonia as a transport vector, particularly in the Middle East, we're involved in a number of large-scale projects in that regard. So as Toyota mentioned around the shipping channels, you know, pace is important to establish an export industry in hydrogen. Pace is important, and in other parts of the world, you know, they're certainly very focused on dominating that transport vector space. If I jump across to the UK, they have a slightly different approach again in the deployment of this. This is about, you know, tackling the hard to abate industrial clusters in the UK. So the UK government is very focused on deploying hydrogen at the volumes from steam methane reforming, but coupling it with carbon capture and storage to make sure that they can decarbonise, you know, industrial clusters, but also blend in hydrogen into the gas network. And, you know, this is the model in the UK at the moment. It's very much around industrial clusters, and hard to abate sectors is where our hydrogen expertise is being deployed. So hopefully that's a nice run around the world around, you know, how is the hydrogen play unfolding? You know, the only ask I would have of this audience perhaps is not to pit one form of hydrogen against the other. You know, I hear a lot of debate and challenge about green versus blue versus grey. It is one miracle at a time. We need to get hydrogen off the ground. And once we get the demand side sorted, I have no doubt that we will move rapidly to decarbonising that because it makes commercial sense. So thank you very much for your time. Much appreciated.
Thank you so much. Are you still available for questions?
Yeah, of course.
Any questions? Oh, that's too bad. This is fascinating, and we're running ahead of time. Oh, sorry, please come forward to the microphone. Thank you.
Thank you, Andrew. Anthony Douglas from HRL Technology. Just interested in your take on carbon capture and storage, given that's obviously a bit of a sensitive area at the moment. Where are you seeing it actually demonstrated, and what's the area that's leading? Are there projects which are actually in the ground at the moment, shall we say?
Yeah, great question. Look, it's not without controversy, carbon capture and storage, because it's seen as a bit of a band-aid to enable continual dependence on fossil fuel. You know, I think, you know, economically, without a price on carbon, you know, business will not get serious at exploiting the potential of a carbon capture and storage solution. At the moment, a lot of companies are doing it for perhaps different reasons, but I think to really put a rocket under carbon capture and storage, it needs to be economically viable, and there needs to be economic value in capturing carbon. So I think today there are 29 plants running around the world. Some of them are struggling from a technology perspective. Some are struggling from an economic perspective. In fact, when I was living in Houston, I was at the decommissioning ceremony for a carbon capture and storage facility because it no longer was commercially viable. So again, I think, you know, hopefully a global carbon price or equivalent will make carbon capture economic, and business will then start to pay attention to really drive the technology. But at the moment, I would say the outcomes are mixed, albeit there is definitely some successes starting to unfold around the world, and we need it.
Hi, Andrew.
No, please speak into the microphone, otherwise the rest of
Hi, Andrew. My name's Jacob from Metso Autotech. I guess just following on from that question, I think you've made a compelling case for this transition let's get going, and then we can worry about moving from grey to blue to green. In terms of like retrofitting or upgrading existing facilities, like organizations are quite worried about having stranded assets that they've invested billions of dollars in. Like, how much scope is there for, retrofitting a blue hydrogen production facility and then converting it to green, and, how much, not wasted capital, but how much capital is going to get invested that then doesn't really have a use in 10 or 20 years?
Yeah, that's a great question. I think, our operators and our clients are grappling with that problem right around the world. And I think we're seeing more hybrid plants, hybrid hydrogen plants where they are decarbonising their current hydrogen production. So they are bringing carbon capture and storage onto their steam methane reforming, but alongside it, committing to electrolyzer technology alongside that. So we're seeing a lot more hybrid hydrogen development on brownfield assets, which is very encouraging. I think, the worst thing that we could do to the planet is completely walk away from the brown assets and build new shiny stuff over here. We have to apply our expertise and muscle to the hard to abate sectors. And it may be unpopular, from a Facebook perspective, but we just need to be objective about that. And again, clients are increasingly blending green hydrogen as part of their, decarbonisation on existing hydrogen facilities, which is wonderful. Yeah.
Please introduce yourself, Gordon.
Yeah. Hi, Andrew. I'm Gordon Chakadze. I'm with Swinburne University. I was very interested in your case study, which you pointed out on the mining trucks. And I'm just wondering, in terms of the actual commercial feasibility of that, where do you see that becoming, fully implementable? In other words, what's the time frame you see mining trucks running around a mining site running on hydrogen?
Yeah, great. No, thank you for the question. So make no mistake about it, this project across the global portfolio will only go ahead if it's economically viable for this customer. And to make the project or the portfolio of green hydrogen plants economically viable, there has to be total transparency. And this customer has been fantastic in showing us, what is the cost of diesel and maintenance on these trucks today, and how can we then undercut that through a green hydrogen portfolio. So we've had to partner with the electrolyzer providers and be completely transparent on the cost build to try and optimise the project together. And I think only working in total transparency and total partnership like that will we be able to get this project off the ground. At the moment, this particular customer already has a truck running on hydrogen at a mine site. So they've got their fuel cell sorted, integrated onto the truck, and it's working. But I think, we don't want this to stop it being a demonstration, theoretical project. We want this to be a globally competitive project for all of their mine sites. So we're not there yet in terms of making it commercially viable, but we believe that before certainly the end of Q1, we'll be in a position to say, yes, we can make this stack up on its own in the current, subsidy environment and different mine site locations, etc. So yeah, we're working it. The truck is running around now, but clearly, we don't want one truck. We want 450 trucks running on hydrogen. Yeah. Great question. Thank you. There might be miners in the room that may have a good experience as well. So.
Thank you for that. Just a different angle. I'm Daniel, and I was really interested, puzzled by those 9 kilograms of water per hydrogen. And you mentioned that in certain places you may have more water than you need. So can you delve a little bit deeper on that? Because I only have heard that water will be scarce around the world. So to what point do we ship water around because people need water versus we're making fuels with it?
Exactly that.
Yeah,
look,
so can you go a little bit
yeah,
deeper?
I can.
I
think I'll stay with the mining example because it's a very relevant example where some of those mine sites are located where the scarcity of water is a big issue. That they don't have enough water to maintain an appropriate standard of living in the local community, let alone run the mine, let alone make hydrogen. So that is a real challenge. I think this is where sort of the ESG commitment of companies is really tested. because to turn up in a community and drive up the price of water because we're using it to make hydrogen, you know, is a non-enduring approach to broader stakeholder management. So in the mining example, you know, it is building a desalination plant that not only services the mine, not only produces green hydrogen, but also improves the water availability to the local community. And this is why a portfolio approach across those green hydrogen projects is really the only way to make sure that at a global level, at the bottom line, this makes sense. And as I said, as much as we want the green hydrogen plant to be standard, there are some nuances around that. So companies like Veolia have very module solutions, very efficient in dealing with these types of issues. So it's again about integrating partnerships and seeing what's possible together. Yeah.
Please introduce yourself.
Hi, Andrew. Adam Champion from AMP Control. We've heard a lot about electrolyzer technology and the supply chain around it. Could you educate us a little bit on where fuel cells are up to and what factors around fuel cells and their technology might influence the demand side going forward?
Yeah, I'll be perfectly honest, that's probably an area outside of my area of expertise. My sense is now it's moving beyond beta testing to commercial deployment. And there's even a very innovative Australian company called Lavo that's building hydrogen electrolyzers for storage on residential properties, which again has some compelling advantages over battery storage for households. So I think, you know, I can't comment specifically other than to say, you know, more and more of our clients are coming to us for green hydrogen production because their fuel cells have moved to a point now where they can do that. And particularly in net zero transport around bus fleets, particularly in Canada and in London, you know, we're doing a lot of net zero transport work there because fuel cells on buses have become, you know, commercially feasible. So sorry, I can't answer that more specifically. You've got me. Great.
If any other questions, otherwise I've got one while you think of another one. So there was a German-Australian feasibility study about the supply chain of hydrogen, and they almost calculated to the penny how much the transport would add to the kilogram of hydrogen. Have you got a similar number for CCS? I really do wonder, with the current high price for natural gas in Europe, how that would even, how CCS would even be remotely viable. However, if you say, oh, they're cheap and don't worry about it, well, then I'm fine with through hydrogen. I understand how you need to find the bulk volume, but I struggle to make commercial sense.
Yeah, look, that's a great question, and you know the economics vary so broadly around the world. You know, cost per ton of carbon capture that you know the carbon trading schemes that are available to those companies in the different parts, and of course policy really affects that. You know, I think more broadly, carbon capture and storage may not make economic sense in some applications, but I do worry that if we turn away from brown assets and leave them in their unabated state, you know, what a hell of a mess that leaves. So I think we have to find a way, and I think with a global carbon scheme, that I think that will be a major enabler. But the skepticism is an appropriate one, because in some parts of the world it does not make sense without significant government funding, and therefore, you know, are green technologies better to leapfrog it altogether? And in some answers, the answer is absolutely yes. So especially when you keep hoping that methane emissions will not be penalized. Exactly. Any other? Yes, Vicky, please. You can still introduce yourself. There might be one person also in the room who doesn't know.
I'm Vicky, I'm from CSIRO. I actually just want to pick up on that water comment. I can't remember who mentioned it, but I think it is important to compare that with current use of water in how we are extracting minerals from the ground for export. So yes, it is, you know, you put 9 kilograms up for every 1 kilogram of hydrogen, and that by itself looks like it's a great deal, but please benchmark that with, for example, 2019 export of LNG, the equivalent, I think it was energy in that, if we were to do it in hydrogen, is I think 2.5% of Australia's consumption of water and less than half of what is used in mining currently. So can we please, you know, when we look at some of these numbers that are up there, and yes, some are scary, but let's compare it with what we're currently using in terms of our resources for what we're exporting or digging out of the ground.
Yeah, that's a fantastic point. Thank you for making it. I met the CSIRO last week actually on ammonia, and the CSIRO have done some incredible work at looking at the total energy input, you know, of using ammonia as a transport vector, and then lining it up against, well, what's the best alternatives, and being absolutely wholesome in the assessment. I think that's a fantastic point. Thank you, Vicky.
Right, thanks. One last question. Yep, come forward.
Very quick, Rob Dickinson again. I just wanted to supplement Vicky's very intelligent comment. It's crucially important to mention also that whereas hydrogen from fossils, you're throwing away the water, you're trashing it, you don't get it back. With green hydrogen, it's recreated at the other end, at the consumption site. You don't lose anything.
Circular economy, thank you.
Okay, thank you so much. It was a very, very fascinating presentation. Thank you. So we move to our first panel of this afternoon, and it is moderated again by, and I've updated my pronunciation here, Bryony O'Shea. Sounds better than this morning. I'm so sorry, Bryony. I hope you can hear me, and I apologize for my mispronunciation of your beautiful name this morning. And Bryony will be moderating the panel, Seeking More Application Scenarios for Hydrogen Utilization.
Hi, thanks so much, Florence, for that second lovely introduction. It's very kind of you. It's great to be back this afternoon. Andrew Tan, it's great to see you back again this afternoon. There's been a lot of really interesting discussion throughout the day, a great lead-in discussion just now about hydrogen production technologies and all of the factors that play into the economics of the different colours of hydrogen. So we're going to focus this afternoon on seeking more application scenarios for hydrogen utilisation. And I'd like to just introduce the panel before we kick off. So we have, as I mentioned, Andrew Tan, President and CEO of Chiyoda Oceania. We have James Hamilton from BayWa Renewable Energy. Dr. Stephen Percy from the Victorian Hydrogen Hub. Stuart Anderson from Pascal, and David Waterhouse from Hypersonics. So we have a combo, as you can see, of online and virtual panelists. And I suppose GPA have had the fortune of being involved in projects looking at a number of end-use applications. And through our involvement in both the Future Fuels CRC and the HILT CRC, looking at heavy industry, low carbon, and also mobility, we've had quite a look at applications for hydrogen. But in fact, it's the panel that are going to give us far greater insights to the various applications and opportunities for the use of hydrogen. So I'd like to not waste any further time and hand straight over to Andrew to talk a little bit about Chiyoda's focus on applications for hydrogen. Over to you, Andrew.
Yeah, I think as I said in my previous presentation, the main game is using our technology to store and transport hydrogen around the world, and we're looking to start this in 2025, going into Singapore and to Europe through the Port of Rotterdam, and all being well, using our technology to start the hydrogen economy. So I think I'll hand over to, was it James?
Over to James. Thanks, Andrew.
Thanks, Andrew, and thanks, Bryony, for the introduction. I think it's probably safe to say that BayWa is the largest renewable developer that you've never heard of. Today, we're active in 28 countries with over 10 gigawatts of wind and solar under management. management. Is when a 600 kilowatt wind turbine was the industry standard, to a period where a 1 megawatt battery was considered the largest in the Southern Hemisphere. And we're on a similar experience curve and entry point for hydrogen currently. So I find that very exciting. And I'm also very keen to leverage the group's operational experience and expertise in green hydrogen to understand how we can both seed and accelerate the establishment of an Australian hydrogen economy. So looking forward to today's panel discussions, and I'll hand over to Stephen.
Thank you, James. So I'm from the Victorian Hydrogen Hub. We're a government-funded research centre looking at how to accelerate a hydrogen economy in Australia by engaging with industry and doing research and building those sort of core projects now and the understanding we need. So we're working in areas such as the social licence. One of my colleagues is working with local councils and engaging with them to really understand that social license piece. We have another program, which is the Hydrogen Readiness Program. So that's engaging with industry and the consumers potentially of hydrogen, and really trying to educate them now and get them sort of understanding how they can sort of start planning to start consuming hydrogen in the future. And then there's the part that I'm working on. This is in hydrogen modeling. So we're looking at how to, modeling electrolyzers. And also we're working with Patrick Gore, who presented yesterday on the National Hydrogen Infrastructure Assessment. So we're evaluating the infrastructure to deliver a hydrogen economy in Australia. Another modeling piece is that I'll probably mention later on is modelling of the green hydrogen price at every renewable energy zone in Australia, considering the optimal mix of wind and solar in that. And this ends up being a forecast of hydrogen price in Australia, and looking at where the best places are to be producing hydrogen, and should you be doing that from wind or solar or a combination. So yeah, I'll hand over to the next person.
That's myself. Yeah,
Stuart?
yeah. Hi there. So Stuart Anderson, I'm calling from over in the UK. So I'm part of Haskell. We front up a hydrogen refueling infrastructure team, and we create global solutions for the hydrogen mobility sector. The unique thing about Haskell is we specialize in the movement storage of high pressure gases and liquids. As part of the wider sort of Ingersoll Rand business, we're able to provide the full turnkey solution, the manufacturing, assembly, and testing of turnkey solutions and shipping globally. And we're working with a number of projects and partners in the APAC region, such as ATCO, Core Gas, Haringa, which I believe you were speaking to yesterday, and Red Bus. So yeah, looking forward to getting involved with this discussion. I'll hand over to David.
Hi everyone, David Waterhouse, CEO of Hypersonics. I think we've got a quick video to show because it does a much better job of explaining what we do than I do.
Space has always fascinated and inspired humanity. Now, in the age of connectivity and information, we're taking to the skies every day. As the demand for spaceflight soars, so do the opportunities. We've seen more satellite launches in the last few years than the entire history of human spaceflight. With thousands more small satellites expected to launch over the coming years and a projected market worth $10 billion, minimizing our impact on the planet is critical. This new era of space needs new, considered technology. Most space launch companies rely on non-sustainable launch systems, increasing pollution in our oceans and atmosphere. In the face of a rapidly growing market, this approach is not cost-effective, conscientious, or sustainable. It is time for change. It is time to fly to space. Hypersonics is pioneering the future of the industry through affordable, sustainable spaceflight technology. We fly to space using the Earth's atmosphere to soar like a bird. There's no need to carry oxygen. We're powered by clean, green hydrogen, so there are no CO2 emissions. We aim to be completely reusable, so you can rely on us over and over and over again. Here's how it works. Our Delta Velos vehicle flies like an aeroplane. Able to place a satellite in orbit from any launch site, it offers quicker turnarounds and more launch windows. Inside the Delta Velos, our Spartan engine draws oxygen from the atmosphere for its fifth-generation air-breathing scramjet. Green hydrogen fuel provides thrust at 5 times the efficiency of any rocket, and its only exhaust is water vapor. The Delta Velos can accelerate from Mach 5 to Mach 12. With no moving parts, it's also inexpensive to build. The satellite launch process, like any space launch, is split into 3 stages. Stage 1 sees the boomerang boost the Delta Velos to Mach 5. True to its name, it then returns to where it came from. Delta Velos is stage 2, flying to the upper reaches of the atmosphere under scramjet power. When the Delta Velos reaches terminal velocity, it launches stage 3, delivering the satellite to orbit. Velos returns and while this may seem revolutionary, hypersonic staff have been involved with scramjet technology since 1995.
After I completed my doctorate in aerospace engineering, I had the absolute privilege of working at NASA's Langley Research Center. My job each day was to think about new ways to design scramjets.
Our staff have proven flight heritage from the High Shot and High Fire programs and have performed more than 6,000 scramjet ground tests. It's this knowledge and experience that has led directly to the foundation of hypersonics and the creation of our reusable 5th-generation scramjet made from composites, hyped by the Australian government, and work with dedicated and passionate people at Boeing and BOC. By leveraging development in the growing hydrogen economy, we're providing a groundbreaking alternative to current technology. The Delta Velos prototype is under development. It will soon be flown to prove our speed, reusability, and range. And the potential for hypersonics technology extends beyond space. A clean hypersonic airliner, which could take you from Sydney to New York City in 2.5 hours, is on the horizon for hypersonics. There is a global imperative to develop a sustainable green economy. Let's lead the way to the future and fly to space together.
Thanks, Dave. That was quite an intro. And I'm not really sure where we go from scramjets to space, but I'll kick off the panel session regardless with a question, James, for you, if I may. Certainly, as Dave's video highlights, we've seen a lot of creativity and variety in the application scenarios for hydrogen. Perhaps to a large degree, we do know what the landscape looks like. And you made a comment to me in our lead up to this session that we need to prioritize what makes sense. Suggest we don't need to get too creative in the short term. Can you tell me where you think we should be investing our efforts in establishing a viable hydrogen economy and what application scenarios we should be considering first and foremost?
Sure, thanks for the question, Bryony. So I guess to start with, the audience largely accepts that hydrogen is going to be disruptive and it has this ability to sector couple across markets and applications, and the impact is going to be immense. So the natural gravity of that environment is to cast the net pretty wide and to look at a huge range of potential applications. And I think that is a really important activity, particularly from an academic perspective. But when it comes to identifying commercial entry points for green hydrogen, particularly when we talk about public subsidy being a significant mechanism to establish a lot of those markets and those applications, I think we really need some focus and some prioritization. And I think the risk, if we don't do that, is we end up diluting that available funding mechanism, and none of those applications end up receiving sufficient oxygen that they achieve critical mass, and we can push them down the learning curve and start to deliver some really near-term commercially viable technologies. So I guess where that original comment came from was around a need to sort of navigate that landscape and to try and identify where the obvious entry points were for green hydrogen establishment. And at least in my own personal perspective, that's not a particularly difficult landscape to roadmap. We've got, a huge amount of noise and a huge amount of background activity, but some of the questions I like to ask are, are proponents investing significant amount of equity from their own balance sheet in terms of seeding and establishing these markets and the opportunities and the projects? And if the answer to that is no, I think we can sort of fairly rapidly move on to some of the other opportunities. And one of those markets that I really like is the existing use of hydrogen. We use a huge amount of grey hydrogen. So globally, the number is around 90 million tons. If we were just to transition that sector to a green hydrogen alternative, we'd be looking at over 1,000 gigawatts of electrolyzer capacity. And to put that into perspective, we don't currently have one in operation. So that in itself is this huge market opportunity, very ambitious. And I don't necessarily think we need to look too far to the left or to the right of certain entry points for hydrogen in terms of being able to settle on applications which are both near-term commercial and can deliver scale in terms of scaling to then see tier 2, tier 3 applications. I guess that just in closing, I think that's where a lot of the operational experience that BayWa RE have amassed has really informed our internal strategy. It's really looking for to distill that strategy into one sentence: applications where the hydrogen is providing molecular value above and beyond simply just burning it or combusting it. So some of the markets I particularly like are wastewater treatment. You can monetize both oxygen and the hydrogen. Remote area power, particularly because you sort of decouple the market from this need to hit, a $2 per kilogram price metric. Neither of those markets moves significantly in terms of scaling the overall hydrogen economy or the opportunity. So I think where I kind of end up after that circular argument is grey to green is this huge opportunity. And I definitely think that should receive the bulk of the attention and the majority of focus in the short term in terms of getting some tangible projects realized.
Yeah, thanks, James. You make some really good points. And when you put the numbers into the discussion about just how much existing grey hydrogen demand there is to be replaced, it's quite remarkable. So perhaps from between those extremes, if you like, Stephen, I'm going to ask you a few questions because we're all aware that mobility is very much a hot topic in terms of application scenarios for hydrogen, particularly in parts of Asia that have a higher population density and perhaps the critical mass needed to transition to fuel cell electric vehicles. But in Australia, given our geography and our population and perhaps even policy settings, amongst other things, it's harder to imagine that transition to hydrogen passenger vehicles, for example. But heavy haul perhaps provides an opportunity. you've done a lot of modeling across a number of scenarios, but I'm curious to know what your modeling tells us about when hydrogen might become competitive with, say, diesel.
Yeah, thank you. So I think it's been mentioned quite a few times over the last couple of days that passenger vehicles don't make a lot of sense. And the main reasons for that are cost of the vehicles, range, and you know, when you compare that to a battery electric vehicle. When you think about a freight vehicle, it's a different picture. So freight, you need a longer distance, you need to refuel quickly. If you were to do a battery semi, that battery will deteriorate over time, so your range will reduce as well. And that doesn't happen with fuel cell electric vehicles. So the thing that has come from my modeling, and I can expand on that a little bit, but we're looking at the renewable energy zones and how much we can produce, what's the minimum price we can produce hydrogen at each of those zones, and how does that change in the future? And what we find initially is that the lowest cost hydrogen is actually coming from far north Queensland and actually Tasmania. And to achieve the lowest cost hydrogen actually requires a mix of solar production and wind production. And what we find from this, if we look at the adding, you know, a fixed transport rate to those cost projections, we find that diesel actually becomes cost competitive with hydrogen becomes cost competitive on a per energy basis with diesel by about 2023 in the best case. And that's requiring that optimal mix of wind and solar to achieve that price. In that you have to obviously factor in the higher price of that diesel vehicle in that cost comparison. That's something we're beginning to look at now. But we're potentially seeing that as one of the really, you know, but one of the great opportunities in the short term is that transport option. So, yeah. I also wanted to say it's really cool to see the space application. I'm a bit of a space nerd myself, so it's really good to see that on the panel.
Thanks, Stephen. I agree. I wanted just to say scramjets. So that's really soon. That's really soon that we can expect to see parity with diesel, at least in some parts of the country, and it's very encouraging. To perhaps
Brian,
markets.
Am I able to ask a quick question?
Oh, please do.
Stephen, I'm really intrigued by this whole mobility play. Given what you just said, which I completely agree with, you know, let's assume that hydrogen has lost the opportunity for passenger vehicles given competitiveness with battery electric. Does heavy freight and commercial fleet application in itself present a large enough market to scale to justify, you know, the significant infrastructure deployment that would be required around refueling and distribution and storage? Keen if you've got any insight on the viability of heavy freight as a standalone activity.
Yeah, so I can put some ballparks on there, but probably not maybe. Transport in general in Australia is about 16% of Australia's emissions. Of that, I think it's it's about I don't have the number in my head right now. Sorry. So probably I think it's about 10 to 15% of that is trucks. 5% roughly is buses. So there's huge potential to do that, especially along freight corridors. And I think one of the things with the freight corridors is that they run through the renewable energy zones. And so you can potentially produce green hydrogen next to the freight corridors and move that along to refueling locations. And that's actually something we're beginning to think about at VH2 is how you plan for those decarbonizations. And we're beginning that feasibility study. So James, I'll definitely have some more details for you probably in the next sort of 3 months on that.
I think we'll all stay tuned for that, Stephen. It's a fascinating sort of ongoing series of modelling that BH2 are undertaking. So to move to the international space, Andrew, Chiyoda are obviously focused on international markets and a number of applications for green hydrogen. And Chiyoda are involved in a number of different applications. So what are some of the other decarbonisation opportunities that you see happening outside of Australia?
Oh, thank you for the question. No, first of all, I'd like to acknowledge, James, you mentioning the current use of hydrogen is quite significant. And I think everyone needs to understand that we already use quite a lot of hydrogen, and that is significant. Look, going back in time, hydrogen was first introduced as a energy replacement for LNG and coal. So mobility and the stuff we're talking about in terms of the transport sector was never, I suppose, never really a big percentage of that. The main percentage was how do we replace to get there because of the turbines. Well, currently they're available, but they're still expensive, and technology hasn't caught up. But other opportunities, we don't have to look far. As what James has mentioned. Existing refineries that people talk about refineries, oil and gas is dead, but it's not. I can assure you that. And existing existing customers, for example, and this is publicly available, so I can talk about it. So the ENEOS Corporation in Japan, for example, use a significant amount of hydrogen in their refining process in Japan. So they are actively pursuing ways to reduce their carbon footprint. So that's one way of using hydrogen in their existing process. Then, of course, you've got the ports that also want to decarbonize, and power stations. So what we did in 2020 was essentially bring hydrogen into Japan and combust into a power station. Whilst it was meant to power the Olympic Games, it never happened in 2020. We did do it in 2020. But that does also, make people aware that it is possible. So that there are companies out there, for example, GE, Mitsubishi Power, who currently have turbines that can combust 100% hydrogen. It's just they're expensive, and it's going to take time to get there. So I suppose another method would be to use it as a big battery. So whilst we talk about the battery that we know and love, the Tesla battery in Adelaide, for example, there's other ways to store this energy and for combustion in times when the wind doesn't blow and the sun doesn't shine, or there's not enough rain. So there's many ways, different ways you can use hydrogen, we don't have to look very far to start finding existing technologies and industries that currently use hydrogen.
Yeah, thanks, Andrew. You've made some really good points about existing industries and applications, and I know Stephen's done some really good modelling on oil refineries as well, so we'll come back to that. But I do want to just make sure that I speak to all of the panel first. So Dave, great video.
Yeah, glad you liked it. You can see why it's much easier to watch that to have me explain. But
I do like it. I'm curious to know how far from commercialization you think we are for hydrogen-powered space travel.
Well, we're doing a technology demonstrator launch first quarter 23. So commercialization, I think the aerospace sector is one of these sectors which is naturally well suited to hydrogen. The technology's been around for almost 100 years, but we've been a little bit lazy from an engineering point of view. And I think my point is, for us, it's been this perfect storm of we've had the hydrogen economy kick in, we've had the computer modeling, the composites, and now we've got this huge demand for small satellites coming up. And really, hydrogen in this way is a disruptor or a catalyst for disruption, not just in the space launch sector, but we believe the whole aerospace sector. So the scramjet technology we're using for launching satellites, eventually we could also use it for airliners. And that disruption is not just, great speed, of course, we all love that. So that adds to economic efficiency. But as well, we use a lot less hydrogen. I use 10 kilos of hydrogen to travel 2,500 kilometers at Mach 6. Now you compare that just with the volume of fuel I'd have to use to travel 2,500 kilometers in a plane. So I think it's very important what we talk. We spent a lot of the conference talking about the supply side. On the demand side, there's a real opportunity now to look at using hydrogen in other ways. But the theory's been around for years, but now we have that commercial drive and the opportunity to make some real changes, real disruption. And again, I'm obviously keen on space and aerospace and everything else, but I'm sure there are other sectors as well. I think the fuel cells, the electrification makes a lot of sense for a lot of different applications, but anytime, the great thing about hydrogen as a fuel, if you look at the energy per kilo, which is important when you're using the atmosphere, it's really great. And, if we can get the hydrogen infrastructure in place, that opens up whole new opportunities. And that could really help create new demand, which in turn helps the business case for the whole hydrogen economy. Does that sort of make sense?
Yeah, it certainly does. And I think when you consider all of the various industrial sectors that have a carbon footprint, and you overlay that with the difficult to abate sectors, I think people like Stephen have a long future of modelling to do to start to work out how we can chip away, perhaps that are achievable in the short term, are supported and foster progress opportunities are sectors. But now, thanks for your patience all the way over there on UK time. A lot of markets, both in APAC and beyond, learned that you've
also a very exciting sector at the moment. I think it's fair to say that in certain parts of the APAC region, so Europe went in very ambitious, aiming off for a large sort of HGV sort of market, thinking that they come at a point as far as Europe was concerned, was the vehicles weren't there to support it. It was that whole chicken mature market. A lot of the OEMs are bringing the vehicles to that. And I think the European market's almost taken a step back. So they went in thinking medium term, sort of 20, 30 vehicles, HGVs, almost a demonstrator side on, what does a network and infrastructure look like? And I think that's key to this. And there's a lot of some really good case study there is a very clear route from to the actual compression and dispensing. A lot of demonstrator products can furnish the whole range, and we can have small demonstration location solution. Going forward, I think there's a trend towards HGVs definitely, and actually 700 bar vehicles to stations as well.
And feel free to keep sending them our way, because there's, I guess, one thing that's really true about the hydrogen economy is that obviously we all benefit if we can move forward as quickly as we can, and we've certainly seen that with a lot of our work and partnerships with. So we talked opportunity to use hydrogen within sort of a hybridized storage platform. And we've talked a little bit about things happening in the right order as well. So I'm curious about what you think. Do you think there's room for hydrogen as a storage medium in the electricity system in the short to medium term? Or are we just talking about that last 10% of decarbonisation? In which case, what's the opportunity for remote area power stations as you see it?
Yeah, thanks for the question, Bryony. It's almost my favorite question. It comes up a fair bit in terms of what's the role for electrolyzers in network facing applications. And unfortunately, the answer is quite direct. Hydrogen is a terrible battery. That's why it doesn't compete effectively with battery applications that can be electrified. Listening to Michael Ottaviano from the lunchtime session, he put it quite concisely when he said, first of all, we need to electrify everything that can be electrified. And I very much agree with that. Outside of that, the difficulty with using electrolyzers for demand management applications, so network services, is largely around providing an offtake for the hydrogen. So the value stack for electrolyzers needs to be quite complicated, and part of the reason for that is the hydrogen offtake itself at typically $5 to $6 a kilogram isn't fully recovering the cost of production. But a more interesting dynamic I'd like to talk to is just around the difficulty in getting an offtake, and comparatively the ease with which that's achieved in the European market. There's established trading aggregators and market mechanisms for exchange of hydrogen and feeding them directly into commercial industrial mobility ventures. That doesn't really exist in Australia, in fact, offtake for hydrogen in this market. And I think one of the reasons I see for that is almost this marriage between the renewable sector and big oil and gas. And in terms of the roles across the hydrogen value chain that I see each entity taking, the renewable sector is there ready to build capacity, ready to invest equity, but there's really serious questions about who's going to buy it, what volume do they want, what price do they want to pay. And those are questions that I feel oil and gas sector proponents should be able to answer. They're trading in essentially these gas-based commodities currently, and they're making a lot of noise about hydrogen, right? There's a lot of support for, we need to interrogate some of the motivations behind those interests and say, is it cynically just a play to convert liabilities on the balance sheets to assets? And is that the role that's attractive to a lot of this interest around green hydrogen? Or are we actually talking about significant investments in future infrastructure to transition and hydrogen derivatives? I don't really know the answer to that, but I think in terms of the near-term commercial application for hydrogen, offtake is really difficult. And the last part of your question was sort of talking to remote area power, which is somewhat of a silo market in itself. I find that market hugely exciting, not for the ability to displace diesel, but one mitigating significant impact on the combustion dynamics at very low energy shares. So if you can think of a diesel engine, putting 0.5% or 1% hydrogen into the air intake to fumigate that combustion process, that has a really effective impact on allowing that asset to run a lot more flexibly at a lot lower load. So partial load, low load applications, those have historically been very prohibitive for diesel gensets, restricts the ability of the thermal assets to load share. If you can use hydrogen as this bridging technology that lets thermal assets run a lot more sustainably at low load or even load, what you do is you unlock 20 or 30% or more available utilization for the existing solar or the existing wind. So hydrogen certainly has these niche applications where it is really exaggerated, and I'm hugely, it's never going to scale to be a huge hydrogen demand. Green hydrogen, we're talking about supplementing the combustion process to make that more amenable to high renewable penetrations. So a very, very long, complicated answer consolidated down to a very short answer. No, there's actually very limited near-term commercial application for grid-connected electrolyzers, but that's one of the areas we're actively exploring in BayWa to help de-risk that from sort of the 2030 timeframe out.
Thanks, James. That's really interesting. And Stephen, I know from some of our discussions, you made the point that interseasonal storage for electricity and export are important, but similarly, you found that they may also come later in terms of commercial viability for those particular applications.
First
Can you tell me what
to make on
in your modelling drives
seasonality, now you bring it up, is that that obviously in the renewable production there's a season system that also impacts the amount of hydrogen we can produce on a daily basis or on a month, based around season. And if we're looking to provide an export market, which is maybe wanting a fixed amount every month, or providing vehicles which need the same amount delivered every day, there's an impact around the seasonality of being able to deliver that hydrogen. When it comes to storage, and if we're talking about the electricity network and storing hydrogen, I agree with what James said, is hydrogen is not a good battery. It might make sense if, for example, there's an oversupply of hydrogen and you might need to do something with it, and then putting it into a gas generator might make sense. In terms of storing it and competing with battery storage, I think that's going to be really hard to do, unless hydrogen, or at least feeding back into there's a couple of gas generators that can run on hydrogen. There's the one in Kurri that's under development. That could potentially take a mix of hydrogen directly without much modification. So that actually has applications, but we're so far from that making much sense.
Okay, thanks, Stephen. So perhaps to move away from both the grid and from mobility, I'd like to talk a little bit about heavy industry now. And the point has been made, Andrew, that green steel is potentially the single biggest disruptor and step change to decarbonisation. And I'm sure actually that could be said about a number of heavy applications. With the recent successful establishment of the Heavy Industry Low Carbon Transition, or the HILT CRC, we should expect to see some increased research and focus on the decarbonisation of heavy industry in Australia. But again, I know that Chiyoda is focused on a number of larger scale applications. So I'm curious about your observations of progress and barriers to the uptake of these applications.
Yeah, I think there's been lots of discussion of how we green steel, and there's talk about let's use ammonia as well. I mean, issues there really be what you do with the NOx and nasties from ammonia at the end of it after combustion. But look, from I'm not an expert on the greening of steel, but essentially it's just replacing the existing grey hydrogen with green. But talking about progress, and that's why we end up in Brunei. But now, if I say I've got a demonstration project, I've got people lining up to tell me they can supply it. So I think progress has come exponentially. Has progressed well since the first days when people couldn't spell hydrogen. But the barriers to entry really are cost. And bottom line, companies still need to make money, and companies still need to survive. But so cost is one, technology is another. That there are the technology is advancing all the time. It's just that we currently live in a world that wants everything today and doesn't want to accept that we have to take little baby steps. But I think collectively as a panel and everyone else in this conference, we're all trying to do that. We're not trying to hinder any of this. It's just a difficult situation to say that we're getting there, but little baby steps.
Yeah, I think you're right. We all have to hurry up and be patient. But it's great to see so many, such a variety of applications discussed even just within this particular panel session. I would like to make sure that we've got time to ask the audience if they have any questions. It was a little difficult from where I'm sitting, to be honest, but if we could perhaps get some guidance as to whether we've got any questions from the audience.
Maybe I can just fill that void while we're preparing some questions. One of the interesting applications what's the role for Australia in sort of the global context? And the obvious answer to that is kind of export of energy with hydrogen as the carrier, or a derivative. But I actually see a significant opportunity in terms of qualifying technology supply out of Asia Pacific, particularly China. Stephen just talked to the cost reduction that we need to see on electrolyzers and fuel cells to hit these price parity targets. Chinese supply of those components is a significant step change in realizing some of those drastic cost reductions. And Australia has historically played a fairly important role in qualifying that type of technology and demonstrating that it's financeable and that it's compliant with essentially international acceptance and quality standards and everything else. And I think that's an important role we will play as we kind of accelerate the transition to low cost green hydrogen. So pretty keen to hear from the panel and from the audience, if there's some thought bubbles around that on that opportunity as well.
Brownie, we do have a question from the audience now.
Okay, I'll give your audience member an opportunity to respond to James's question as well, but thanks, Florence.
Hi, my name is Philip. I'm from South Korean Government Trade and Investment Agency. As you might aware, in Korea, we have a company specialized in hydrogen application of hydrogen utilization. My question is do we have any, does Korean company have opportunities to available here in Australia among Korean companies, Australian companies, or international company here in Australia? So what sort of opportunities are available for Korean companies?
So in terms of VH2's objectives, we're really interested in engaging with international consumers to understand their requirements and sort of advise our research. So on the research side, absolutely, we're interested. And that's an opportunity we would like to explore.
And just to add, BayWa RE is actively exploring some of those relationships, primarily because we have offices in South Korea, in Japan, import markets for a green hydrogen commodity. And the answer is yes, there's a lot of dialogue between relevant government ministries and big established industrial conglomerates about how you firm up that collaboration and partnership. And I imagine you've already seen some of that enterprise announced, but over the next 6 to 12 months, expect to see more of it, because it is going to be a big focus of how we do.
We have another question.
I think just to respond to Philip, I think on behalf of all of the organisations represented here, we all see a wealth of opportunity to work with South Korea or Japan or any other particular nation or company interested in working on the development of a hydrogen economy. It's just a case of us connecting. Thanks, Flora.
There's another question. Would you like to come forward and introduce yourself again?
Yeah, thanks. Rob Dickinson again. Power fuels, electrolysis, is a demand valley filling technology. Batteries are a generation time shifting technology. They're not the same thing. I don't know anyone who is seriously talking about spending money on hydrogen competing with batteries. If anyone does know anyone who's serious about that, I'd be interested to know, because I'm going to tell them to do something else. Is that a question or a comment?
I think Toyota would be an obvious receptive counterpart to that claim, but yeah, interesting perspective. One of the projects that we're working on that's potentially controversial is hybridizing storage from batteries and electrolyzers as a long-term storage complement, and how you coordinate that, how you optimize the sizing, how the dispatch scheme then would prioritize value from either technology. And that actually looks quite promising. Obviously, in today's climate, the capacity equivalence of the electrolyzer is a very small percentage of that total storage entitlement, but each technology does have respective benefits. And I guess you're right in arguing that they're trying to achieve different things. It's not necessarily the case that they have to be competitive applications.
I just wanted to, while we're on the topic of batteries, we are actually looking, well, because electrolyzers are behind the meter battery, coupled with the there's our initial work sort of shows to produce more hydrogen and bring the levelized cost down by actually storing some of the renewable production, oversizing renewables, and then being able to store some of that electricity in a battery. But we're still sort of evaluating that. And I think that'll actually just only be a real short-term way to reduce the levelized cost. But that is another, link between hydrogen and lithium batteries or flow batteries or, yep.
That's great. Thanks, Stephen. Do we have any other questions, Florence?
No, not as far as I can see.
I think that might make for pretty good timing then. So just to wrap us up before I hand back to you, I would like to give my sincere thanks to my panelists, Andrew from Geoda, James from BayWa, Stephen from BH2, who I'd love to see more of the modelling that you've done. I think it's fascinating. Stuart from Haskell, particularly for the time of day that it is, joining us from the UK, and Dave for that super cool video from Hypersonics. Thanks all of you for your time. And hopefully we'll hear more about these applications for hydrogen in the future. Thanks, Florence.
Thank you so much, Bryony. That was a great panel, another great one, and the last one before the coffee break or refreshment break. Let's see what we will be served, and then we'll see you again for the last session of the day at 4:20, so in half an hour's time.
Hello, Sala. Are you there? This is Erin from MCEC.
Yeah, hello.
Hello, how are you?
I'm good, thank you.
That's good. So I'm just one of the technicians. I'm just testing to see if your audio is clear and you sound clear, so that's good. I'll just need to see your webcam. That is great.
Perfect.
All good. I just need to ask a question. Are you screen sharing your presentation for the next presentation time?
Yes.
It's around 4:20. Yeah.
Yeah.
All good. 1 second, please. Are we able to just quickly test your screen sharing ability?
Yeah, 1 second.
Okay, that is good.
So I'm sorry. Can you see my screen or just the presentation itself?
I can see your screen at the moment. You're in PowerPoint.
Yes. So now if I move to
Presentation. Yep.
there we go. Perfect.
Oh, it hasn't hit presentation mode yet.
It hasn't. Okay.
No. I see you've pressed presentation mode, but I'm still seeing the sidebar and the slides.
Yeah. Is there a way actually to 1 second again? What about now?
Yep, that is perfect.
Okay, so it seems that actually I need to go to the presentation mode before sharing my screen. Okay.
Okay.
Great.
No, that is all good. Just see if I can. Yep, no, that is perfect. Okay. Yep, you are ready to go when the next session begins. That should probably be in approximately 10 minutes time, but stand by. And you'll see our room camera focus onto the lectern of the chairperson who will start presenting and introduce you. And that's when you'll begin your presentation.
Perfect. Thank you very much.
That is all right.
Right.
Good luck.
Thank you.
Mais en général, c'est plutôt ça. Welcome back to the last session of this afternoon. First up, we have a virtual speaker, Salah Mahdi, who's going to inform us on advances in hydrogen compression solutions. Salah is a senior executive with over 20 years of business management and sales experience with Howden. In her portfolio of experience, we have oil and gas, renewable energy, so much more, chemical and petrochemicals, ammonia and fertilizers. She is the lady to go to this afternoon for giving a competent speech on her topic. Please welcome Salah.
Good afternoon, everyone. Can you hear me?
Yes, we can hear you. We can see you. You can fire away.
Okay, thank you very much. Okay, so good afternoon, everyone. First of all, I'm really sorry for not being to make it to Melbourne to be physically with you today in this great event. But at the same time, I'm really happy that I'm having this opportunity today, really to speak and talk to you and contribute to this great event. My name is Salah Mahdi. I'm the Global Director for the Renewable Hydrogen Vertical in Howden Group. As mentioned, I came from initially oil and gas background, worked for companies like Poly Parsons, UOP, Honeywell, but later I moved completely to the clean energy side, worked initially for companies like IT Empower and others, where I delivered a large number of studies as well as projects, a number of them actually already running across Europe especially, and also including one of the largest green hydrogen, green ammonia in this space in the Middle East. Before jumping to the main subject of the today's presentation, I would like to seize this opportunity and quickly introduce Howden Group, the company that I'm working for. So Howden is a global company. We have been in the business for over 160 years. Roughly, we are 6,000 people operating from roughly over 90 locations worldwide. And as you can see, also, we have over major 22 manufacturing centers and over 12 service centers, again, globally. We have been serving a number of industries, oil and gas, power, industrial, and others, as well as also the renewable energy, which includes the hydrogen business vertical. We sell what we call air and gas handling solutions, anything from compressors, blowers, heat exchangers, fans. And we have been serving the hydrogen actually business, I would say the gray hydrogen business for over 100 years now. Actually, we invented since then larger number of key technologies that now considered to play a key role in this industry nowadays. We are very active in the hydrogen space. We are very active member in a larger number of global and regional key hydrogen associations, as you can see here, from the Hydrogen Council, Hydrogen Europe, to the Australian Hydrogen Council as well. As a global company with this large global footprint, we have a strong global aftermarket and service capabilities. We can easily step in wherever our customers' projects is, whatever the time is, we can easily step in, help them really to make sure that they overcome any issues, any problems in their operation, to make sure that they have a smooth operation. Our main offering, as you can see in the hydrogen space, is basically the compression solutions. And a key differentiator for us is our very wide portfolio. Almost our portfolio includes the vast majority of the solutions that you would need actually in whatever the hydrogen application is, which is actually something that give us a great opportunity to give our customers unbiased advice every time we work with them, depending on the nature of the projects, the customer requirements. We easily can give them, again, unbiased advice with what could be the right solution, the right technology that fits very well into their projects. As I mentioned, we have been really very active in the clean energy side, in the hydrogen business side, delivering really projects. Starting with the fact is that Howden has built the largest hydrogen compression solution in the world, and that, to be honest, was on the gray side for KMBC in Kuwait. Having said that, hydrogen, as you know, is hydrogen. But also because of all what I have said, the long history, the fact that we invented key technologies, the global footprint, our technologies have been selected really to be in the heart of very unique and important projects for this industry. Collected few here, examples as the first e-fuel plant in the world in Chile, in South America, the largest hydrogen refueling station in the world in China, and the first green steel project in the world in Sweden, as well as one of the first green refineries project in Europe working with Shell, as well as also the largest biofuels project in Europe and Shell refinery in the Netherlands. So as you can see, real projects. So we passed, I would say, the study phase, and now we are busy in delivering projects. A different mix of applications, steel, e-fuels, power to X production, reflects really, again, how busy we are in this space. So now the question is why compression is important, why we believe that the compression actually play and is important actually for the hydrogen value chain, for advancing the hydrogen economy worldwide. I think it all starts from the fact, as you can see here in the graph to the right, the fact that the hydrogen has a very low energy volume on the volume basis, energy density. And knowing this, that means that the hydrogen, in order to be used effectively, it has to be used at a large volumes and with high pressures. This is really needed, and this is basically the function of the compression. And this is again the reason behind what I said, that the compression really across the value chain, as you will see, plays a really key role here. So yeah, as I mentioned, because of what I have said, this is basically a high-level scheme for the hydrogen value chain, starting from the production, transportation, and storage, and then the different application on the utilization side. And as you can see, there is a need for the compression everywhere across the value chain. On the production side, regardless actually the way or the type of the hydrogen we produce, green, blue, we still need a hydrogen. On the transportation side as well, whether it's through a pipeline or even converted it to another form of a energy carrier compound like ammonia or methanol, we still need the compressors. On the source side as well, again, with the fact that we need to, as I said, use it at very large volumes, also you need compressor to make sure that you can store the hydrogen at large volumes. And eventually on the utilization side, on the mobility side, or the power generation or building heat, still the compressor really play a key role in across the hydrogen value chain. So what does it mean? I mean, the first thing is the fact that, again, the compressor is something that plays also a role in minimizing the total levelized cost of the hydrogen. And as you can see in the graph to the left, depending on the application where it actually sits within the hydrogen value chain, but the more we move from across the hydrogen value chain, from the production to transportation and so on, the bigger role the compression actually will play, because basically you're adding more compressors to the game. So selecting the right technology, selecting the most optimized and efficient technology definitely will contribute to this equation here. With the fact that this, when you look into the hydrogen value chain, especially on the production transportation side, I would say from another angle, the most power consuming, the major two power consuming equipment in this space are basically the electrolyzers and the compressors. On top of this, also is really very important to highlight the fact that it's not just the CAPEX, as you can see here. So I have selected one of the applications. This is basically represent the hydrogen refueling station project. And based on the analysis that we did, it's not basically the CAPEX that contributes to the or largely to the levelized cost of the hydrogen, but as you can see, it is actually the OPEX. Again, that's another reason that selecting the right technology really will play on the longer term a key role in minimizing the overall levelized cost of the hydrogen to the levels that will make these kind of project financially feasible. So knowing this, we always encourage really our partners, our customers to get engaged with their partners on the compressor supplier side. So knowing how critical the role they play in the hydrogen value chain is there are really great benefits that you can get actually from making sure that you engage them early enough on your business side and on your project side as well. So this is, for example, in the projects side, there are a lot that the compressor suppliers, actually vendors, can really do on project side, while definitely on the first level delivering I would say the regular deliverables, cost estimates, data sheets, and so on. But the most critical in this space is really the fact that, you know, we can work together to select the most optimized, I would say, a scheme, screening all the different options that nowadays the customers actually, or the project developers would actually start with. You know, what kind of technology that fits well into the application, what are the requirements, and every application across the hydrogen value chain actually has its own nature and has its own requirements. So understanding this early in the beginning gave the two sides actually the opportunity, as I mentioned, to optimize everything, optimize the hydrogen value chain, optimize the economics of the project, and to make sure that also they reduce the total cost of the ownership for this project. And I mean, again, depending on the applications, but usually it is the footprint is critical, the reliability and the availability is critical, high efficiency, safety, all of these parameters actually are things that we put initially in our consideration, working in this very early phase to make sure that, again, we selected the right solution that will contribute in advancing the economics of these kind of projects. Not only on the project side, to be honest, but actually also on the business side, as you can see, especially when you have a longer-term plan to deliver projects business in the hydrogen business. Also, it is really important to move from, I would say, the project's point to the business points. You know, to focus not just on the short-term plans, more into the longer-term plans and the strategies. And again, we have seen really great values that both sides actually can get out of this relationship. From one side, as I mentioned, delivering the commercial project that they have, but also working together in understanding the requirements of what we believe the future project in this space will need, creating or inventing what we can call the market or the industry future technologies. Again, it will contribute back to the points that have been mentioned, the cost, the efficiency, reliability, and minimizing the total or the overall cost of the hydrogen production. Looking into different things, as I mentioned, this is really something that we have done, and we have started working with our partners in this approach in parallel, again delivering the projects, but as well as thinking about the future and how we can help you know, both sides really to deliver up to the expectation and help, you know, the economy, the hydrogen economy, the global hydrogen economy in general, to move to the next step. And here in my last two slides, I included what could be considered as really a good example of this approach. This is the hybrid project in Sweden, the first green steel project in the world with them. So this is something actually we did early this year, where we started actually the year before for months with hybrid. We sat together, we studied all the different options, and considering that, again, that was one of the early projects in the world in this space, so a lot of options have been considered, different schemes have been studied, and we worked together really from one side to understand the different schemes, evaluate and select the right one. On the compression side as well, we evaluated the different technologies after understanding the requirements, and eventually after months of discussions, months of studies that both sides actually did, we eventually were able to select from one side the right technologies, the right compression technology, which eventually helped them to select the most optimized scheme for their plant that actually nowadays is running and delivering the green steel. So a key requirement was from one side that definitely was the fact that they need the hydrogen with a very high priority. Contamination was a great, with a major requirement really to avoid. Also the reliability, since we are talking about large volumes of hydrogen. Also the safety has been really a critical issue that took a great part of the discussion, how to make sure that whatever the equipment actually contributing to this project is really from the safety perspective will deliver with no issue. Especially as I mentioned, also we are talking about large volumes of hydrogen stored underground. And as well as also on the reliability side, this is a continuous process in great part of it. The hydrogen actually used in both as a fuel on the energy side, but also on the process side as well. So the reliability also was a key and comes really on top of everything. So understanding these requirements and understanding the challenges. So Howden has been able, working with hybrid, really to select the diaphragm compressor, the diaphragm compression technology, which is an equipment that can really deliver a hydrogen with a very high purity and with a great reliability. We are happy actually that we're working with them delivering this unique project, and we look forward actually also for the next project that they will do. So again, this is what we consider that really a good example of what kind of values that both sides actually can get. Missing one thing in the early engagement phase that we had working together definitely would lead the project to a direction that could potentially wouldn't be the right direction for the project. Last slide is really just to highlight that Howden in Australia we have a long history in Australia. We have been in operation there since 1950, so over 70 years now. We have different offices, service centers almost everywhere, and we have a larger team. So I hope that you found the presentation useful. If you have any question, please feel free to reach me out, or actually my colleagues who are actually in the room today. Thank you very much.
Thank you so much, Salah. That was great. Any questions from the audience? If not, then I will introduce my own panel and ask my panelists to come to the stage, please. One of the upsides of this panel is you get to sit in the comfy chairs for once in 2 days. That's fantastic. I'm looking forward to that. We will be talking about supply chains and export. And I'm not sure if Martin is here. Hero? Is this working already? Yeah, sounds like it. Awesome. Great. So I will just very briefly introduce my fellow panelists, but they are going to just say something about themselves and the companies they work for, and then we'll go into the questions. So next to me, we've got Hiro. His full name, of course. No, I'll give it a go. I've made a fool of myself so many times today. Hirofumi Kawaso. not too bad. His mother company is Kawasaki, which is well known and much more easy to pronounce. Would you like to say something about yourself?
Hello, everyone. Hiro Kawaze, my name. My mother company is Kawasaki Heavy Industries. And I'm working for Hydrogen Engineering Australia at this moment. And HEA, we call HEA. HEA is undertaking the HESC project, Hydrogen Energy Supply Chain Project, to produce hydrogen from brown coal and export to Japan as a liquid form. Yep.
And that's just down the road in Gippsland. Thanks for being here, Hiro. Gordon Chakaotsa from Swinburne University of Technology. He's just joined the VH2 Hydrogen Hub in this year. Gordon.
Thank you, Florence, and hello, everybody. So I'm Gordon Chakaotsa, and I'm a director of the Victorian Hydrogen Hub, VH2 at Swinburne University. You heard a bit about our work at the last session from my colleague, Dr. Stephen Percy. But essentially, VH2 has been funded by the Victorian government to work alongside industry to help solve some of research questions and help make hydrogen implementation a reality. Our founding partners are CSRO and also Arena 2036, which is based at the University of Stuttgart in Germany. So I'll talk more about VH2 as part of the panel.
Right, thanks, Gordon. And we all know Matt Baumgürtel by now, who is a partner with Hamilton Locke and a fantastic panelist. And I hope you haven't lost steam yet, because we need you at this panel tonight. Thanks for being here.
Certainly not, and thank you, Florence. Very happy to be here.
Great, awesome. Let's kick off with an aspect that hasn't been discussed very much in those last 2 days, and that's going to be research. So Gordon, would you like to give us a bit of color around the role of research in advancing the hydrogen economy and potentially even international collaborations?
Yeah, sure. Thanks, Florence. So I think research is an extremely important area around making hydrogen economy a reality. We've heard from the last day or two, the industries such as mobility in hydrogen, decarbonizing steel, ports, and in all those sectors, I think they're going to need some form of research to help them in terms of the companies or organizations involved in that space to make it, those to help decarbonize those sectors. So at VH2, we have assembled a research team that is doing exactly that. So an example of that was the modeling work, which my colleague, Dr. Stephen Percy was talking about earlier on in terms of how he's working with various industry partners. But we'll also be, assembling PhD students and master students that are going to be doing some really groundbreaking research over a 3-year period. So they'll be looking at areas such as decarbonization of ports, for example. And it's not just your traditional university research they'll be involved in, but working alongside industry. So we have started discussions with, some companies in the port sector, and they will be involved in those research projects. We'll be looking at decarbonizing steel as well. So we've got a PhD student who will be coming on board on the team to work with industry around decarbonization of steel. We'll be looking at decarbonization of aviation. So as part of Swinburne, we've also got another program called the Air Hub, where we'll be working together in the aviation sector to look at how industry can decarbonize in aviation. So to summarize, I think it's a really important sector. Obviously, the companies are doing what they're doing on the commercial side, but there will be a gap there in terms of some research questions, and certainly VH2, we stand ready to support that.
That's great. Especially, I'm really curious to see what pans out with the aviation. There's so many. You're smiling. What are you thinking, Matt?
Oh, I absolutely agree. Mobility, transport is the reason why we need a hydrogen economy. You electrify everything you can, and the rest you've got to do something else with. It's sort of high intensity, high emissions industries, and that's transport. It's marine, It's air transport and it's trains and trucks as well.
What are you betting on in terms of aviation? What's going to be the fuel of the future?
Wow. Smarter people than me will tell you that hydrogen is reasonably close to avgas. You know, you can that you get a similar calorific value. So so I think that there's the aviation piece, and we've already seen Boeing and Airbus have plans for, the last one I saw was 2024 for Airbus to have a hydrogen plane flying. Now that's very different. That's very interesting.
Very interesting.
And I'm sure that ties in with what you're looking at.
Last number I heard on this was 2035 for regional aircraft and 2050 for long haul.
I think commercial ones, absolutely, but first plane to fly.
I see. Yeah.
Fly first, I guess.
Hiro, would you be able to tell us about Japan's development in aviation? Have you got any targets there or any?
So Kawasaki Heavy Industry, my mother company is, you know, it's very known about motorcycle, and also we are producing some parts of the aviation, the aircraft body, and Kawasaki's hydrogen sector was very small before, but now we are expanding the resource and yeah. So not only the aviation, but we are aiming to develop some like hydrogen train or motorcycle or like airplane or something. So yeah, so the hydrogen used mobility sector will be realized.
That's right. Yeah. So we all know that Japan does have a target to decarbonize by 2050. What exactly is that looking like? Like, for example, in Germany, they said no more internal combustion engine fueled cars by 2038. So that's a clear target. Have you got any goals in between now and 2050 in Japan?
So Japanese government target 30 Japanese yen per normal cubic meter in 2030, which is $3 per kilo in 2030, and the final target is $3 per kilo in 2030 and $2 per kilo in future. And to aim to achieve that goal, Japanese government announced the Green Innovation Funding Program, which is Japanese government put the money on the green energy program, including the hydrogen.
That's fascinating. I hadn't heard much about the Green Innovation Fund in Japan before. So that's, would you be able to give us a number, how much money exactly they were putting on the table?
Yeah, so the Green Innovation Funding Program is, there are various programs, including the hydrogen, like liquid hydrogen is one of them, and also like electrolyzer or hydrogen gas turbine or something like that. And KHI and other two companies, ENEOS and Iwatani, awarded funding program. It's a $2 billion funding project. And it's for establishment, large scale liquid hydrogen international supply chain.
Wow, an international supply chain and funded with 2 billion Australian dollars.
US dollars, sorry.
US even more, oh my goodness. That's great. So, and coming back to Gordon's point, do you also have international research collaborations?
So at this stage, now currently we are undertaking the small scale pilot demonstration. And in this pilot demonstration, we collaboratively working with CSIRO. And yeah, in the future, we haven't decided yet how we can collaborate with Australian research organization, but yes, we are very positive to collaborate with them.
Because we hear a lot about Japanese companies being active in Australia. Are there many students yet, or do you think there will be more of a student exchange? And is it even potentially on the cards that Australian students might go to Japan to learn from Japan?
Yeah, I think it's possible. Currently, it's very difficult timing, but yeah, But one key issue is the language barrier. Maybe I'm saying, but a bit difficult for us to speak English in such a.
Well, sure. But no, look, we're speaking in English here at this panel. And one of the primary schools my kids went to was teaching Japanese. So I think actually, Matt, that's something that's pretty common in Australia to teach Japanese. So that shouldn't be too much of a barrier. Gordon, what's your experience with the students? I mean, of course, COVID has been slowing the process down, but when do you find that you have students active in the hydrogen field from particular countries or interest from particular countries in a sort of research or student exchange or PhD, or is it mainly one given country? Like you just mentioned Germany.
Yeah, sure. I think you can probably look at that in a number of components. So I think in terms of the VH2 programs and the research team that we've assembled with currently and are looking to assemble, the closure of borders have made that somewhat challenging in terms of identifying or bringing in or selecting candidates from overseas countries. So, but certainly I think, that situation is improving. So we expect that, we'll be able to include researchers from and students from internationally to be part of the VH2 program. So that's one component. But and the other component, I think, in a broader issue, I think in terms of the projects or the hydrogen economy in Australia, I think that has got a potential to attract international students to come and study about hydrogen in Australia. So one of the programs we're working with in VH2 is what we're calling the skills roadmap. So really working with the industry to understand the current gaps in terms of the hydrogen economy now, and actually start to develop courses for the future to support hydrogen economy. So, Swinburne, I think, certainly looking to develop courses to support in the hydrogen economy. And, given that there's a lot of international students at Swinburne, we expect to attract students from all over the world to study those hydrogen-related courses at Swinburne. So, yeah, there's a couple of ways to look at that.
Mm-hmm. Matt, do you find that industry is talking enough to universities to cover the need for training?
I think that you can reflect on the success of solar engineering is now taught at lots of different universities, and I think that if it sounds like the programs that you're pushing forward in Victoria and also in other universities I'm aware of, they're great programs to create that knowledge base and that knowledge sharing. What I'm interested to understand, I think, is also how are you engaging with the hydrogen commercial community? And do you see yourself as a connector of those businesses in particular? Of those businesses in particular, because I think that there's a real opportunity there to be a connector. And then you alluded to it as well, Florence, the exchange of students, the exchange of academics, I think is a huge opportunity for hydrogen community globally.
Yeah. No, thanks for that. Yeah, so absolutely, we see ourselves as a connector as well, particularly in that SME space. Because if you look at the SME space, I think there's a lot of questions from a lot of companies of what hydrogen means to SMEs and how they could adopt hydrogen for their own businesses. So what we're doing through a VH2 readiness program is really working with those SMEs and then connecting the dots with other partners. So, if you look at some of the companies that have sponsored this program, for example, they're some of our industry partners, and we are constantly joining the dots that perhaps you should talk to this company on something you're working on. So yeah, we're connectedly, sort of making those connections for on the commercial side as well.
I can attest to that, because also through your membership with the German Chamber of Commerce, we try to connect you as well with some interesting companies. And that's how I know that you have actually 18 fully funded PhD students to collaborate in the hydrogen sector with companies, which I find is a great move and should be a total win-win in every respect. That's great. So we were also going to talk a little bit about domestic production. What are realistic ways to ramp it up? Matt, would you like to kick us off on this one?
To my mind, domestic demand is key. And I'm on the record saying that, you know, if you demand it, they will come. People will build it. People will supply it. There are lots of different strategies to support demand. There is a big role for government and for semi-government organisations to lead the charge. They can do that by cutting checks, which is pretty blunt, and perhaps not the most efficient way to do it. But they can also do it via, you know, the government is a huge demander of services. They're a huge buyer of diesel. They're a huge buyer of petrol for their vehicle fleets. So if those vehicles were hydrogen, then there would be an automatic demand for hydrogen. And even if those vehicles, so by government demanding those vehicles, the efficiencies in economies of scale of production are created at the vehicle level. By the government then demanding and then creating a demand signal for fuel, people will create the fuel. And if government only buys green hydrogen, then there's a demand and a premium paid for it. So we need to remember that both federal and state governments, states and territories, are a huge buyer. They're a huge demand source, and I think that gets lost a little bit. All the procurement, all the probity things are very, very important, but government has a huge checkbook and it can create demand, which will kick away industry.
That's a great aspect that I don't think I've heard in the last 2 days. We have heard about regulation policies and financial support, but just that purchasing power that the government has and on state and federal level is quite remarkable.
It's an easy one. And it's part of, it gets buried sometimes, but it's part of the Hydrogen Roadmap, New South Wales strategy, that they will slowly go into that. And it doesn't get necessarily the bigger, it's not a headline, right? It's not $3 billion of free money from the government, which is what politicians like to lead with. But the implication of government buying a vehicle fleet or transitioning its fleet to electric and to hydrogen vehicles, not only the demand for those vehicles, but the demand for the hydrogen required to fuel those vehicles over the next 10 years is a huge demand signal to industry. So I think that in itself is arguably a multiplier, a complete multiplier of the first spend. You know, the vehicles cost whatever they cost, $200,000 each or whatever it is. Buy enough of those, plus that it's the actual flow-on effect. It's that the economies, the macro drive.
Hiro, I'm sorry if I'm making you the official speaker for Japan here, but can you see the Japanese government using its purchasing power to accelerate this kind of development?
Yep. So as I mentioned that, so green innovation funding is one of them. So the government target is to reduce the hydrogen cost. And then, as I mentioned, one of the green innovation funding project is to develop the large-scale hydrogen gas turbine to develop the power. It's clean energy. So once the cost will be reduced with government support, and then the GHG will be reduced, and so.
And the project you work for, the HESC project, so we are expecting the first ever vessel built by Kawasaki to transport liquid hydrogen, which is going to be a historic moment. I hear my chances to be on the guest list are not very big, but I did try. Now, how is all that hydrogen going to get into Japan? Is Japan saying, is Japan just shelling out the money to build those vessels, fully accepting that they will have to transport the hydrogen into Japan? Or is Japan banking on exporting countries such as Australia to manufacture those vessels?
In Japan, we don't have a much resource, so we need to rely on the overseas resource like Australia's natural gas or brown coal as well. So yeah, so from the Kawasaki's perspective is to build a special ship to transport liquid hydrogen and to deliver from the liquid hydrogen from Australia to Japan is one of the key target. And,
Have you got more ships in the pipeline?
Pipeline in Japan, maybe not, because we have lots of earthquake. So yeah, so deliver as a liquid form. So in a liquid form, we can reduce the volume of hydrogen 1/800. So it's quite efficient to deliver.
Otherwise, you've always got ammonia that you can transport with existing vessels, correct?
Yeah.
Have you got more HESC projects in other countries, or is Australia the only country you're really partnering with in terms of hydrogen?
So HESC project is one only the country much advanced, and yeah, we are looking for some opportunity various projects because to achieve that $2 per kilo, I mean 20 Japanese yen per normal cubic meter, we need a lot of hydrogen supply chain project, not only the one project. So in order to achieve that, we need a lot of hydrogen energy supply chain project, including Australia or other countries as well.
Matt, do you find that companies that are setting up to produce hydrogen, do they make the decision as to provide hydrogen domestically or for export purposes from the start? Or is that a decision that can be postponed to later on depending on off-takers and amount produced?
I think the large projects are focused on export markets, and they are banking on a demand in Japan and Korea and Germany and other places, so Australian projects. They are long-term projects. We heard earlier today from Andrew Dickinson at CWP, and others are focused on export markets for their ammonia, for their green ammonia. Those projects are 2 or 3 at a minimum years away. I think we can move now between now and then to use the hydrogen that they're going to produce, their green hydrogen that they will produce in their testing phases and their pilot programs, to create a domestic demand that will decarbonize our sector. That hydrogen will be quite expensive, like renewable energy was when it was, solar panel energy was very, very expensive to make in the first instance. But now look at it, it's the cheapest form of energy globally, just in a period of 10 very short years. So I think that's the opportunity so I wouldn't describe it as build a project for domestic demand and then build a project for international demand. I think that you pilot projects, they're relatively small. You need to export at scale to make it efficient. So that hydrogen is, it must be for domestic consumption, whether it be for fertilizer, whether it be for explosives, whether it be for mobility. That to me is the domestic demand piece. It's a relatively small market, but it's a stepping stone. And the great thing about it is that as soon as you start to export green hydrogen at large volume, whether it's liquefied in ammonia, compressed, whatever it is, the cost per kilo comes down substantially. The efficiencies, the economies of scale are there. It's the same as the LNG economies of scale, which means that at that point, you've supported a domestic market, you've subsidized that domestic market via the cost of hydrogen. But now that market is now going to benefit from and will arguably explode because you've now got economies of scale in making green hydrogen. So you're just taking export, you get an export price and you get an Australian onshore export price, not a delivered export price for that hydrogen. So it's a transition. It's lumpy, but it's a transition. It's a scale level. So I think the interesting project, the HESC project is very interesting on that basis because it'll prove that you can do the supply chain. We've heard a lot today about supply chain. That is supply chain. that international supply chain. The domestic supply chain, I think, is something that we could move much faster on, and we can do it at that pilot program, that pilot scale, 1.25 megawatt electrolyzers, 5 megawatt electrolyzers, 10 megawatt electrolyzers. They're all domestic demand, domestic supply projects. You've got to go 100 megawatts and a gigawatt to do international demand, I think.
Go ahead.
Just a quick question to Matt. I mean, in the LNG sector, sorry, you saw a situation previously where there was two prices, an export price and a domestic price. Do you see something like that in a hydrogen economy where, you know, there might be a two-tier pricing system for domestic and export?
I think there has to be, because your domestic demand is by definition smaller volume, but you don't have to pay the shipping cost. So you are going to end up with a bifurcated market. Absolutely, you're going to end up with a bifurcated market. One of the great things about hydrogen, green hydrogen, is you don't need a reservation policy because there's plenty.
That's a great point. Earlier, when we heard from John Cockrell and that they've got this 5 megawatt electrolyzer ready, I was wondering, why are we still looking at those 1.25 megawatt? Why don't we just order a few of those?
It will look, yeah, absolutely. And you know, there's big industry who are doing that, and there's people putting money to play, which are at pilot projects that are they're not going to get a rate of return. But because they're large companies that have, it's a very small piece of amount of money for a large business to make that, and this is the Kawasaki play, you can invest, and the government can come in next to it as in in-house project, and help support it. But it's a trial, it's a program, it's a pilot, it's R&D. And that's where I think the really interesting thing for Australia, if we think about Australia's place in the world, we're going to be, if we choose to be, but we're going to be a significant exporter, creator of green hydrogen. And therefore we are going to develop a huge amount of knowledge in relation to doing that. And we have some very, very smart people, very, very good universities to do that. So why can't we, you know, this panel is about exporting opportunities. We can export our knowledge to other, not only producers of hydrogen, the Middle East in particular, but we can also export our knowledge and our technology at the other end, the regasification or the use of hydrogen in, you know, in Germany or in Japan for power production, or Germany for mobility. So I think there's a whole knowledge supply chain that we can also export from Australia. There's an opportunity there that, yeah, so we're the lucky country and the smart country. Well, you know, there's an opportunity to do it.
Absolutely. And just to debunk a common myth, there's more technology that gets exported from Australia into Germany than the other way around. Germany was recently looking for a company that would help it recycle batteries. It's a company from WA. So yes, research is really great here, and certainly also, especially because of that collaboration. Gordon, can you give us a sneak preview into which ones of your disruptive innovations or of your research projects might just potentially see the light of day? I'm thinking along the lines of a solar panel that can act as an electrolyzer and produce hydrogen, or photocatalysis. I mean, just something crazy. Give us something crazy.
I mean, yeah, that's an interesting question. I think, you know, the type of industry partners we're working with are a whole range of sectors, and in a lot of instances we've signed NDAs. I can't speak to too much detail, but you know, I think there's some like exciting projects out there in terms of, you know, you'll be aware of some of the companies that are looking to bring hydrogen powered buses and trucks and garbage trucks, and so we are involved in all those projects. And the aviation space, I think, is another one which particularly excites me as well, in terms of the potential research collaborations we'll do there with the industry partners. So yeah, I'll leave it at that.
There are, just on that point, there are some phenomenal phenomenal technological advances. So there are solar panels that create fresh drinking water that could crack that into hydrogen. That technology exists. There are, and where I get really, really interested is offshore wind, proper floating offshore wind, untethered. It doesn't make it, well, it makes electricity, but it makes hydrogen. And you just take a little boat around, take the hydrogen off. You know, you're basically farming hydrogen in the middle of the ocean. That type of technology exists. Now it's experimental. It's not even, you know, it's being done, but the desalination of seawater and creating hydrogen from that using a wind turbine exists. So this is where the learnings from oil and gas and renewables come together, because that's floating oil rig technology.
That fascinates me too. And that's how I read that. That's how I remember reading that Japan just has an offshore wind sort of island or platform and sends a vessel back and forth that acts as a giant battery. Isn't it fascinating? So yes, in this case, you're circumventing the hydrogen bit. However, with the, let me ask you first, in the first step, is this something that could potentially, that could involve companies from Australia or German companies, for example, with regards to the wind turbines, depending on which ones you use? I'm particularly partial to the rotating ones. And so that would be my first question, which other companies or other countries are involved? And the second question would be, has Japan got enough offshore capacity, to your knowledge, to become independent of energy imports? Sorry to catch you off guard. By the way, none of this is scripted, as you can see. We decided to go free range.
The second question is, you mean offshore capacity, right? I think so. And I heard some news in Japan that some tidal wave power generation or something. And also in some part of Japan, we have lots of wind. So yes, I think we can do that. And what is the first question?
The first question was whether you involve other companies from other countries to, or has Kawasaki, for example, its own pipeline of offshore wind turbines rotating or not?
In the project.
Yeah, has Kawasaki got any offshore wind projects at all?
No.
Okay, so would you there be working with other Japanese companies or with Australian or German or American companies that would that do provide the offshore wind? Sorry, the turbines.
So Kawasaki, we have some capability to build power generation equipment, but it's not so big one. So in R&D, maybe we can work together with foreign companies. And yeah.
And do you, just a second, Matt, do you envision as Kawasaki to use Australian offshore wind platforms? Because just like Matt, I also believe that we've done oil rigs out in the sea. There's absolutely nothing to stop us from making hydrogen out at sea and exporting it. So no one needs to see that from the shore. There's no NIMBY problem here. You could produce the hydrogen there and export it straight away to Japan, for example. Is Kawasaki would of course be in a good position with its vessel to transport it. Does Kawasaki intend, or is Kawasaki speaking to Australian offshore projects about potentially producing hydrogen out at sea and exporting or importing it into Japan rather?
So our purpose is to transport hydrogen by liquid form. So if the hydrogen we produce in offshore, we need the facility to liquefy the hydrogen. So we are not sure whether the hydrogen liquefier can be put on an offshore facility, but if it can, yes, it's possible.
Okay, great. Yeah. Sorry, Matt, you had a question?
No, it's exactly right. The challenge with an offshore wind turbine combining with its own electrolyzer to create hydrogen is that you need to liquefy it, or even take it further and take it to ammonia. So that is the technical challenge. I haven't seen, I have read, but as I think you've alluded to, the liquefaction plant is much harder to modularize, and you lose a lot of efficiencies in doing that, versus you can have very small electrolyzers to make hydrogen. So there's a challenge there of how you store that hydrogen, but hydrogen in a gaseous form could be taken off those rigs relatively easily. So these are the technological questions and opportunities we see, and they're the great ones, given our friends next door in the wind conference. This is what they're talking about, right?
Yep, no, that's fascinating. And too bad Martin isn't here tonight, because he or his company produces vessels for compressed hydrogen. They might come in very handy in that context.
Absolutely. I think the opportunity for, not to speak on Martin's behalf, but the opportunity for compressed hydrogen, certainly at a relatively short distance, I think is there. And it's this opportunity, but there's not going to be a simple winner, in my view, in terms of compressed versus MCH versus liquefaction versus ammonia. There's not one winner. There are multiple, and it's going to depend on the use. It's going to depend on the use. We're not going to put ammonia in our cars, but we are going to burn ammonia in fired power stations, and we're going to use ammonia for fertilizer and all sorts of other things. We're going to need liquid hydrogen for the purposes of our vehicles. That's my view. But I mean, I'm interested in you. So the liquefied hydrogen, will that be used for mobility? Will it be used in vehicles, or will it be used in power stations?
Mainly, we are aiming the power generation.
So gas turbines.
Gas turbine.
So regasification and blending with gas to run through a turbine.
Pure hydrogen gas turbine.
Pure hydrogen. Yeah. What's the largest? I mean, what's the largest gas turbine? Pure hydrogen. I've only seen one in the sort of 30 to 40 megawatts.
Maybe.
GE's got big turbines, but they require a little bit of LNG, a little bit of gas. Particularly on startup.
Keiichi's one is, Kawasaki's one is 30 megawatt, I think.
30 megawatts, yeah.
Yeah.
But I mean, that's a good, I mean, in a year's time, we'll be talking about that being 300 megawatts, I'm sure. And I know that the GE turbines and the Siemens turbines as well will run 100% hydrogen. We'll run 98% hydrogen. 2% is really just for startup. So it's like a primer. But this type of technological advancement is a place for universities and research to further progress and create larger and larger gas-fired turbines using purely 100% from start to finish hydrogen.
Roughly, when was it, 20 years ago, when Germany decided to blend ethanol into the fuel. I did regret that there wasn't more collaboration with Brazil, that has been blending 70% of ethanol and a lot of times 100% ethanol into the engines. And guess what? The Mercedes still kept running. So it wasn't a problem at all. However, and Gordon hates reinventing wheels as much as I do, unfortunately, there wasn't much of a collaboration, and the Germans were doing all their own research because the Mercedes in Germany might run differently than the Mercedes in Brazil for whatever reason. So speaking of this, is there any, in this respect, can we not copy on existing gas turbines somewhere in the world that are already running on 100% hydrogen? Have we got anything like that? Would you have come across any, Gordon?
I mean, I think it goes to the broader question of international collaborations. And I think that's the importance of international collaborations, because you don't want to replicate something that's been done elsewhere. So, countries like Germany, there's some fantastic technology in Germany which is why we have this partnership with the University of Stuttgart, Arena 2036, so that we don't replicate any research that's taken place in Germany already, and we can collaborate and access that research for the benefit of our industry partners here. So no, absolutely agree that, you know, international collaborations are vitally important to understand what's taking place elsewhere from a resource perspective, but even from the technology side of things, which is, you know, why we engage with the German chamber all the time, or with German companies, so that we can be the connectors here to some of the industry partners we're talking to, particularly if there's a specific technology which might be beneficial here in terms of, rather than reinventing the wheel.
Matt, I had a question to you. With the clients you speak to, are they like biting their nails, waiting for a guarantee of origin scheme to get finalized in Australia?
I think it's very, very important to get the green certificate program, to be able to differentiate blue, grey, and green hydrogen in particular, and all the other rainbow colours that we have of hydrogen, because the key driver for a lot of corporates who are going to buy green hydrogen is that it is green, because it's a decarbonisation play, it's an ESG play. So they're going to need certainty, they're going to need confidence that when they put something in the annual report that goes to their shareholders, or they report to the government, their relevant government, that they've bought green hydrogen. They're going to need some form of confidence in that. We can lean on the renewable energy target and LGCs, large-scale green credits for the production of electricity as an example. We can also look to carbon markets, carbon certificates, and the challenge for green hydrogen is exactly the same as that for carbon, in that you need a global certification system. You need, and not to go into Article 6 and everything else in the carbon world, but we'll need something similar. And Australia, and what the CER are doing, the Clean Energy Regulator here in Australia with the Certificate of Origin scheme, is very similar to, and will promote that. But again, it is an Australian certification of an Australian product, and international buyers of that will have confidence in that. But a global market, but hydrogen will be a global market, and some form of recognition across jurisdictions, and ultimately an international organisation that polices those certificates so they can be traded globally. Because once that hydrogen molecule is in a tank, it's hydrogen, which is the great thing about it. But it's also the downfall. You can't paint it green.
And do you find that it's been holding up any projects so far because they've been waiting for that to be finalised?
I think there's confidence that the system will come, the certification system will come. At the moment, everyone is dealing with that issue by creating their own energy. So creating their own renewable energy, wind and solar behind the meter, put into the electrolyzer, and you can have confidence, you can give confidence to your customer that, see that wind turbine turning, that's the hydrogen that came out, that's the hydrogen that's in the tank, and that's the hydrogen you're going to get. It's end to end. That's big mega projects. You've got to build big generation, and you've got to build the electrolyzer. To do green hydrogen and build green hydrogen at scale, we're going to need to harness grid delivered renewable energy. And this becomes the real challenge. And this is actually where the whole international market is diverging. Places like Germany say that unless you can trace back to where, how the electricity was made and guarantee it, effectively behind the meter, guarantee it that it was new renewable energy, it's not, you can't call it green hydrogen. I understand why they're doing that, but I don't think that's a way to accelerate green hydrogen. What we should be doing is saying, if you can buy grid energy, but if you've contracted in that market to buy green energy from a solar farm that puts its electricity into the network, and that you're at the port and you've got an electrolyzer and you take the equivalent amount of energy off at the same time, like it's got to be real in terms of time, you can't do it all day. So you're only making hydrogen when the sun is shining or the wind is blowing. But you use the transmission network, that's what it's there for, use the transmission network to take energy off. And that electron is just an electron. Again, it's not painted green or black, it's just an electron. You put that electron into your electrolyzer, you make hydrogen. In my view, this is my personal view, that should be green hydrogen. And that, if you do that, then you create an enormous, you accelerate the green hydrogen program. If you can call that green hydrogen, and I think validly you can call it green hydrogen, then you've got it's much easier to do that much faster instead of having to do this whole end-to-end project. You talk to the likes of Infinite Blue Energy, or you talk to the likes of CWP, they've taken the other road, but it's a long road.
Yeah, it certainly is. It's a hard one though, because I guess you can go both ways about it, but you just won't have the same customers. So I understand that Japan isn't fussed about the blue versus the green hydrogen at the moment, and will probably accept a certain level of carbon intensity in the end product. In Europe, they are currently debating whether the French nuclear hydrogen is renewable, to be considered renewable or not, which is an interesting discussion. And then at other conferences, you can hear people talk about a complete blockchain system so that you can trace back your electron to this wind turbine and that solar panel over there. Oh no, I actually don't like this neighbor anymore. I'll take the other one. It's quite crazy. So that's where we are with the certification. But Matt, I wonder if you had a chance, this is a famous German song, which is called If I Was the King of Germany. Now, if you had the king, or actually we do have a queen here. So if you had the possibility to present a list, what would be your top 5 things you would like the government to do to support this green energy, green hydrogen industry?
That's a very big question without notice. I think that you've got to create demand. So the government's got to be there creating demand. Then it's got to fill. So number 1, demand green hydrogen in its own, using its purchasing power. So point 1. Point 2, I think fill the gap between the current price of any other hydrogen, the cheapest form. So, completely emitting CO2 hydrogen, fill the gap between that and green hydrogen, whatever that gap is. So make it easy to make the choice to choose green. That I think is, and you only got to do that for a certain amount of time.
Like a carbon price for difference, contract for difference.
It's a contract for difference fundamentally, but it's a little bit, it's the same as a renewable energy target. That was basically, large consumers of electricity, you must buy green certificates and retire them. You are a reliable entity. Now that's sort of the same as, that's a tax in some respects. I'm in favor of people will make the right choice as long as it's not too economically detrimental. So rough numbers, if we say that the cheapest form of hydrogen is $2 a kilo, let's just say it's $2 a kilo, and the cost of producing green hydrogen is $8 a kilo, then there's a game of, well, do you need to subsidize 6 or do you just need 5? Will people pay $1 more for green? What's the the preference? And it might be that you start at 6, but over time it scales back over time. And I don't think that you need to do that. That time period is a relatively short period of time in my mind, because what will happen is the cost of producing green hydrogen will come down substantially. And I think every estimate that I've seen in relation to the cost of electrolyzers and therefore the cost of green hydrogen, or the efficiency of electrolyzers and their cost, and therefore the cost of hydrogen, I look at it and I think about what a solar panel cost in 2011. And we're now talking about a solar panel costing 1/3 of that less in 10 years. And the efficiency's gone up exponentially. So in real terms, you have a much, the technology looks after itself. So, and that's a long answer, and probably giving you 2 points, but I don't think we need 5. I think we need 2. Pick one. Demand would be my answer.
That's interesting. So you wouldn't even be asking for a carbon tax, for example, to level the costs. So you're just happy with the government creating demand.
I'm a realist.
Yes. Okay.
So we're not going to get a carbon tax. That's just not going to happen.
Okay. The IMF today was okay. We've all read that. I'm so sorry. We have been chatting for a while. Let's reserve a few minutes for questions from the audience, if there are any. Yes, please come to the microphone.
We hear about green hydrogen friendly terminals. I would like to understand what is the current situation in Japan in terms of port infrastructure, and more specifically about refueling station, for example. As we are talking about vessels, we need also the infrastructure at the destination. Thank you.
So currently we have something like 120 hydrogen refuel station in Japan, and it's like from north side to south side, it's connected like, I don't know, 500 kilometers or something. So it's now the number of the such a refuel station is expanding, and also, but the port facility, we haven't had a hydrogen receiving port facility yet, and of course we have a one hydrogen liquefaction, liquid hydrogen receiving terminal in Kobe. It's developed under this current HESC pilot project. But I mentioned that one of the, so in a GI project fund, Green Innovation Funding, we will develop one big liquid hydrogen receiving terminal in Japan.
Naushad Haq from CSIRO. I'm one of the team leaders in CSIRO running basically electrolyzer development project. And my question to Gordon, I think I know that you are a lot of PhD students and talking about the courses for skill development. And actually, by the way, I'm also adjunct associate professor at the Swinburne University. So have you prioritized any thinking? What are the courses? I mean, I know some of the universities are running renewable energy courses. Part of that could be hydrogen energy module or kind of hydrogen energy engineering. Have you thought of what are the priorities should be and where that focus should be in terms of designing a course for developing skills?
Thanks for your question. So we are doing that work as we speak. So as I mentioned in the early part of my comments, that the VH2 program in particular is very much industry-led. So we are, as part of the schools roadmap piece of work we're doing, we're engaging with the industry to understand a whole range of sectors, transport, the steel sector, what type of skills that might be required to support a hydrogen economy. So that work will be completed around March next year in terms of that consultation process. And following that process is when we'll start doing, the thinking around developing specific courses. So I guess in summary, it's currently under development. So I'll be able to update you that sort of in the first quarter 2022 in terms of what that consultation has shown us, because we really want to engage with the industry.
That's great. Okay, actually, okay, one more, Jacob.
I'd just like to get your thoughts briefly in terms of whether you feel that we can do more than just be a hydrogen exporter. Like if we look at petrochemicals, minerals, we're very good at digging things out of the ground, or let's say making the fundamental building blocks. We're not very good at value adding. And yeah, I guess I'm just interested to know if you think that we can do more than just produce green hydrogen and then ship it off overseas.
That question would probably fill an entire conference. Who would like to have a shot at a quick one?
The short answer is absolutely. Ammonia is a great example of that, but there are lots of things to do with hydrogen. We should be adding value to that product, but we also should make a ton of it, like lots of it, because we can. And it's about competitive advantage. That is our competitive advantage, and we do have the opportunity to export the wind and the sun.
And that's not to mention any green steel endeavors. I would like to close the panel. Thank you so very much, Matt, Gordon, Hero. It was great to have you. I loved the chat. So thanks so much. Enjoy your evening.
Thank you.
Thank you.
And I'm going to stay on stage for a very brief closing remark. So it was interesting. We've been talking a lot today about the colors and a lot about how it should be the customer or the market deciding which ones they want to go for, but that in some areas, the blue hydrogen might not even be commercial because it might add too much to the price of hydrogen. It was interesting to hear that we need 1,000 gigawatts to replace the current gray hydrogen production with green. That is a tall number. It was also hydrogen is already viable in remote areas. This we knew, but that the remote diesel rebate amounts to 7.8 billion Australian dollars per year. In comparison to this, I dare say the funding for the hydrogen hubs could get ramped up. Someone said that the areas in North Queensland and Tasmania might even be reach cost parity to diesel as early as the year after next. We talked about certification and how that is something that shouldn't differ from the rest of the world because it wasn't going to benefit us. So we've talked about that in almost every panel, and about social license. That was a very interesting talk about how to start the conversation with communities, the H2 acceptance toolkit, and that overpromising was not a good idea if you wanted to ensure social license. We had a great presentation by Chioda about LOHC, so a bit of a different way of transporting hydrogen, and we have touched upon various derivatives and forms of hydrogen, not last here at this panel. We've looked at hydrogen in space. We've spoken about hydrogen as an energy storage. A lot could be said about that. But let me close with just two tidbits that I thought were my favorite take-home messages for today. And the one was that after gold, wool, LNG and coal, let's just now export renewable energy. I think that's my favorite one, followed by progress has grown exponentially. That was a great quote, and that's making me very hopeful for the outlook of renewable energy and especially green hydrogen in Australia. Thank you so much. Enjoy your night.